Morning, everyone.
Good morning.
Dear colleagues, maybe I will start our section. I'm Solomia Fadushko, the section chair of second section, Perfection of Computer Algorithm and Methods at the 6th International Conference on Computer Science, Engineering and Educational Applications, which will held in Warsaw, Poland, 2023. I'm honored to have the opportunity to proceed over this section, which will consist of 31 conference papers presented by respectful researchers from around the world. And I would like to extend a warm welcome to all of you who have taken the time to attend our conference, especially for Ukrainian participants in a big holidays, Easter. And this section focuses on the perfection of computer algorithm and methods which are essential for the development of modern computer systems. The papers presented in this section will cover a wide range of topics, including artificial intelligence, machine learning, optimization algorithm, data analysis, and more. And I'm grateful to the section co-chair. It's Professor Gnatyuk and Dr. Tishchenko and Dr. Izonin for their support. I look forward to the discussion and exchange of ideas that will take place during the conference. And thank you again for participation. And I wish you all to productive conference. And maybe we will start for the first speech. The title of presentation: multi-dimensional ranking and taxonomic analysis of the regional social economic development in Ukraine. The speaker is here. I don't know the name. No. Okay. The next paper is Platform Construction and Structural Design, Passion Fruit Picking and Sorting Robot under the guidance of trees. Maybe I share our conference program. Okay. And we'll find a first speaker. Okay. Your screen. Okay. Maybe we will choose this one. It's the first presentation, the second presentation, third presentation.
Yes, ma'am. Yeah, I'm ready,
Yes?
ma'am. Yes, I'm ready, ma'am. Yes, ma'am, I'm here, ma'am.
Okay, please.
Ma'am, I can share my screen, ma'am.
Share your screen. Okay.
My title is, ma'am, Radial Mean LBP. Yes, ma'am. I can share my screen, ma'am. Ma'am, my slides are visible, ma'am?
Yes, we saw it.
Is it visible, ma'am?
Yes, yes.
Okay, can I start, ma'am?
Please.
Okay, very good morning to all the listeners and viewers across the globe. Myself, Shekhar Karanwal, and I am research scholar in CHC Department of Graphic Era, deemed to be University, Dehradun, Uttarakhand, India. Today, I am presenting my research paper whose title is Radial Mean LBP for Face Recognition. Now, these are my contents, which include the introduction, related works, the proposed descriptor RMLBP, experiments, discussions, and conclusion with future prospects. Now, first of all, I'll start with the introduction. In various fields of the pattern recognition and computer vision, the one class of descriptors which has marks which influence are the local descriptors. These local descriptors are much powerful than the global descriptors. This is due to the extraction of features from different image portions like nose, eyes, ears, mouth, etc. And the features extracted from these regions are integrated to develop the entire feature size. Therefore, the performance of local descriptors are much better than the global descriptor in the various unconstrained conditions. Now, the various image transformations or image unconstrained conditions which significantly impact the performance of the face recognition are basically the image occlusions, corruptions, blur variations, light variations, age variations, scale variations, pose variations, emotion variations, etc. Now, one of the major patch-based local descriptor invented in literature is local binary pattern. Now, LBP is the first descriptor in which feature extraction is done by using 3x3 patch. And LBP has basically two advantages: grayscale, monotonic grain waves property, and less complex method. Now, there are various disadvantages also noticed in LBP, and these are noisy thresholding function, limited spatial patch ability, large histogram size, and ineffective in harsh light variations. Now, as a result, to overcome these demerits or drawbacks, various LBP variants are launched in the literature. Some achieve good results, and in some places, there is a need of much improvement. The main limitation behind the unsatisfactory performance of these LBP variants is the not of building the effective descriptor in the unconstrained condition. In the proposed work, basically, I have developed such descriptor which is called as radial mean LBP in different unconstrained conditions. Now, and later on the slides, I will explain how RLBP works. Now, in basically to reduce the feature size, the compression and matching was done by PCA and SVMs, and the data set used for classification is the ORL. And results suggest that RMLBP is better descriptor than the others. And in the proposed, basically 6 descriptors are implemented and used for comparison, and the others are basically literature-based methods. Now, these are some of the related work which have been taken from the literature. In 9, basically the 2 descriptors are implemented. First one is the neighborhood difference-based LBP, and second one is the neighborhood mean LBP. In ND LBP, basically clockwise direction pixels are compared with each other for making its feature size. And in neighborhood mean LBP, basically feature size is found or the neighbors are compared with its mean. And finally, both the features are integrated to develop the feature size of a robust face descriptor called as ND LBP plus MN LBP. And the result shows that the fused descriptor produce better results than the individual ones, and various literature methods are also outclassed. In 10, Khanna et al. Discovered the emotion recognition method by using 2 descriptors, the LBP and STFT. STFT is the short time Fourier transform, and LBP is the local binary pattern. And LBP used for extracting the local features, and STFT used for extracting the frequency domain features. Therefore, their feature integration is the discriminant descriptor as compared to the individual one. In the third reference, basically, the 3 descriptors are proposed. First one is mean LBP, median LBP, and CLBP. CLBP is basically the integration of the features of 3 descriptors, which are LBP, MLBP, and MNLBP. And it is obvious that when integration is performed from 3 descriptors, that therefore this achieves a better result as compared to the individuals and many others. So these are some of the literature works which has taken from the literature. Now this is the proposed descriptor radial mean LBP. I can explain with the help of this figure, as it can be seen, in this diagram that there is a 7x7 patch is 9x9 patch is taken, and in this 9x9 patch, basically, as it can be seen, these are the rectangular boxes. Now these rectangular boxes are the basic radial pixels, as it can be seen in this block. Pixel set R1 is this showing, this one is the pixel set R2, this one is pixel set R3, and this one is pixel set R4. So at 4 scales, basically radial pixels are taken, and from each rectangular box, which is aligned in 8 different directions, the mean value is obtained. For example, for this box 4633, the mean value is 4. For 6, this box, the mean value is 6, and similarly, the mean value is obtained for all the boxes. And after obtaining the mean values, the 3x3 patch evolves, in which mean values are placed at these neighborhoods, and the median of all these neighborhoods are placed at center. Then the mean value of the neighborhoods are compared with the median of the values for obtain the RMLB code. And those neighborhoods mean values having the value greater or equal to the median value at center are assigned the label and otherwise 0. And after binary pattern is achieved, then weights are supplied to this binary pattern. And after adding values, the RBB LBP code is achieved for single position. This is 187 is a single position code. And by computing RMLB code in every position, generates the RMLB image. And from RMLB image, the histogram size derived is 256. So this is the description of RMLB descriptor. Now, the proposed framework diagram is given below, in which input image is taken and then feature extraction is performed to RMLB, the proposed descriptor, and then compression is performed by PCA. Now, PCA is basically used to compress the features or to represent the features in lower dimensional. As it obvious that the large dimensional doesn't produce better result as compared to the low dimensional features. Therefore, features are projected in the low dimension through PCA. Finally, classification was performed by support vector machines. Now, as far as the experiments are concerned, basically ORL dataset, which is the Olivetti Research Laboratory dataset, is taken for evaluation. And ORL consists of basically 400 samples of 40 humans, and each human holds 10 distinct images acquired in 3 different challenges. And the 3 different challenges in which these images are acquired are light variations, emotion variations, and pose variations. And the image resolution of these images is 112 by 92. Therefore, this size must be reduced to save the computational cost of the execution. Therefore, 52 by 48 is the size which is reduced from the original image size to reduce the computational cost of the execution. Then from this reduced size, basically 7 descriptors are implemented, which are local binary pattern, horizontal elliptical LBP, neighborhood intensity based LBP, local phase quantization, reader difference LBP, 6x6 MBLBP, and RMLBP. This first 6 ones are the proposed descriptor, and last one is the compared descriptor. And all develops the histogram size of 256. And after deploying the PCA, the size used by the classifier is 25. And the MATLAB environment used for the evaluation is R2021A. And the formula which is used for the accuracy calculation is correctly match samples to all the samples in the test data sets, which means accuracy is estimated on the test data set. Now on ORL, basically the other parameter which is taken is TN. TN signifies the training size and TT signifies the test size. So TN values ranges from 1 to 3 and test size value ranges from 9 to 7, which means 1 sample per person used for training, then 9 samples per person used for testing. Similarly, for 2 training samples from each person, the 8 samples are used for testing, and for the last subset, the 3 samples are used for training and remaining 7 used for testing. It means that when 1 sample per person used for training, the 40 samples total are used for training and remaining 360 are used for testing. And each classifier runs 30 times to attain the best classification accuracy of all the descriptors. Now, these are the results obtained on ORL. It can be seen that on every subset, first one is 1/9, 2/8, and 3:7. This shows the basically TN/TT. First one is the TN, which is training size, and second one is the training test size. So accuracy estimated on the 360 test size. It can be seen that RMLBP, the proposed descriptor, comprehensively outperforms all the compared descriptors on all the training subsets. This shows the efficacy of RMLBP as compared to all the compared descriptors. Now, in literature, also 9 approaches are taken and used for comparison to RMLBP. And out of these 9, the RMLBP outperforms the 8 methods. The one method which appears better than RMLBP is distance LBP. The other methods' accuracy are completely outclassed by the radial mean LBP. Now, these are discussions. This work developed the novel local descriptor for phase recognition RMLBP, and RMLBP was introduced to overcome the limitations of previous methodologies. Concept-wise, this descriptor is much better as compared to the others. In case of when overall data set is taken, to reduce the feature size, PCA is used and classification is performed by support vector machines. And as far as the comparison is concerned, the 6 descriptors are implemented and compared against the RMLBP, and RMLBP outperforms all the descriptors, and various literature methods are also outclassed by RMLBP. Now, these are the conclusions with future prospect. In this work, basically, novel descriptor is proposed called as RMLBP. In RMLBP, initially, mean value is obtained from 4 radial pixels located at 4 different radii in 8 directions on 9x9 patch. And this forms a 3x3 patch in which neighbors are filled with the mean values and center PS is filled with the median of those. Ultimately, for making the RMLBP code, the neighbors are compared to the center pixel. And after obtaining RMLBP map, the size derived is 256 for compression and matching the PCA and support vector machines are used. and the dataset used for evaluation is ORL. And results suggest that RMLBP is better and efficient descriptor than many others. Now, there are various ways in the proposal can be extended to future work. Like in this work, this work basically the region features are not extracted. Therefore, if region-based features are extracted in the future, then the accuracy can be improved. And testing on the large-scale dataset also be considered in futures. And the development of the much distributed descriptor in unconstrained condition also be considered in future. Now, these are the 15 references, and then thank you. Any questions, please?
Thank you very much for your presentation. Maybe other participants have a question, some questions? No?
Yes, please. Yes, please. I have
okay.
one.
Yeah. Go on.
Dear Shehar, thanks a lot for your talk.
Okay.
I'm not an expert exactly in this area, but I was just curious, what is like the highest possible accuracy level for this ORL data set? I mean, I suppose you had around like 85% down there or something like that.
Okay.
I'm just curious, what is like the highest possible level, if you know?
So it depends upon the, like in case of the our data, our proposed descriptor, actually I have taken the overall data set and I have extracted the features globally. If I have extracted the feature regionally, then the accuracy improvement can be more, and definitely it can be reaches to 90 to 95%. If regional features are extracted, and in my case, basically I have extracted features globally. I mean, global histogram set of features are extracted.
And we're also interested in some other aspects of like a functioning of your algorithm, like time execution or some complexity, whatever.
Yeah, that will be considered in future.
Okay, thank you so much.
Thank you.
Okay, thank you very much for your presentation. And the next.
Can I stop share, ma'am? Can I stop share?
Okay, thank you. The next presentation will be.
I'm here.
Share? Okay, thank you. Maybe speaker from. Maybe the first speaker join us or no? Just okay. The next is an increased implementation of generalized slide lobe cancer based on based on extraction and maximization algorithm.
Yes, I'm prepared.
Speaker here. Okay.
Thanks.
Please. Okay, I'm stopping sharing. Okay.
Hello, everyone. Good morning, everyone. Today, I'm very glad to introduce an attractive topic, an increased implementation of general silo canceller based on the expectation maximization algorithm. As we know that in several speech communication equipment, such as mobile phone, hearing aids, teleconference, speed enhancement in terms of the speech quality, speech intelligibility, the clarity of the desired speech, and the main part of the speech enhancement is to increase the quality of corrupted noisy speech under numerous complex recording situation. And a single channel is often successful in the channel with stationary noise. And unfortunately falls in non-stationary noise and lead to speed distortion in the desired signal share. And microphone array is one of the most useful common technology uses for extracting the desired speed component while suppressing all background noise interference and third-party talker, and the use of microphone array to extract the speech source and the implementation of general silo canceller informer in the frequency domain is presented in this figure. And the principle of the principle working of GSC informer is using the main signal and the reference signal, ES and ER, and the purposes of the and in this article, the author proposes using the expectation minimum algorithm and the spectral mask would utilize for suppressing speed leak component from the reference signal is derived by from equation 19. And finally, in the ZSCAP beamformer, the reference signal is pre-processing as equation 19. And in the experiment, the author proposed use the dual microphone arrays and the waveform of the original recorded microphone array signal and the processed signal by the conventional ZSCAP beamformer and the processed signal by using the expected EM algorithm. And as we can see that the signal to noise ratio is increases from 2 dB from 2 to 7 dB. And thanks for the attention.
Thank you for your presentation. Maybe some expert in your field have questions, dear participants.
I have, if you don't mind. So could you get back to the slide with the expressions 3 up to 6? Probably, could you please explain what these formulas stand for? Yeah, the previous one, the previous slide. Yeah. Could you please explain what these expressions stand for? I mean, because you have no explanation here.
I understand your question, and thanks for the question. In the ZSCAP beamformer, we use main reference signal, which use delay and some algorithm for focus on the direction of speed source and yes, and the reference signal it's which contain the only noise component. However, in the realistic, the reference signal out a little speed source component that make the performance of ZSCAP beamformer corrupted, and the author suggests use the M algorithm for suppressing the speed leak at the reference signal and increase the overall ZSCAP beamformer performance. And I can explain, and now in this video I can explain the principle working of ZSCAP beamformer.
Thank you so much. And the last question is like, how beneficial is your method compared to some well-known analogs? Just roughly.
Thanks for the question. In in this paper, the author illustrated an experiment in comparison between the conventional ZSCAP beamformer and the proposed method. However, in the future, the author will research and compare it with more known approach such as MVW beamformer or beamformer. In this article, the comparison with the conventional beamformer.
Okay, thank you. Okay, thank you.
Thank you. And dear speaker, we have once more a question in a chat. Could you please tell in your own words, what is the novelty of proposed methods and how it different from existing?
Thanks for the question. In this paper, the novel research is using the EM algorithm for suppressing the speed component, which lead the degraded performance of this beamer, and also successful illustrated and obtain the promising research, and in future the author will illustrate it and will combine with the property of surrounding environment to increase the performance. Thanks for the question.
Okay, thank you for your excellent presentation. And the next presentation is pedestrian identification combined with triple matrix learning and dual domain filtering in noises.
Yes, I'm ready. Can you hear me?
Okay, yes.
Okay, thank you. Then I'll share my screen.
Thank you. Thank you.
Okay, thank you. Then, hello everyone. I am Shurui Wang from Wuhan University, and today I'll talk about our paper, which is pedestrian re-identification combined with triplet metric learning and dual domain filtering in noisy scene. And I'll introduce our paper in 4 parts. First, we'll introduce you about pedestrian re-identification, which is a technology that uses computer vision to determine whether a specific pedestrian exists in an image or a video sequence. Pedestrian re-ID can be roughly divided into 2 types, feature expression-based and metric learning-based. Early extracted features are usually come from handcrafted algorithms such as HAR, SIFT, and LBP. Deep learning technology can adaptively learn the salient features of images and extract more abstract and deep-level pedestrian features. And the other basic idea for, this page is the other basic idea for pedestrian re-ID is to calculate the similarity of pedestrians with methods such as cosine distance and Euclidean distance. And in order to obtain more generalized performance, metric learning algorithm has been proposed. And in metric learning based on convolutional networks, many models uses a loss function as a sample similarity metric function, which reduces the intra-class distance and increases the inter-class distance through supervised learning, thereby improving discrimination. Among them, the triplet loss is widely used. And in our condition, because power systems are usually located in remote and terrain areas, situations such as light change, complex background transformation, occlusion, and so on often occur. Therefore, pedestrian re-ID is still very challenging in actual power grid surveillance system. And for pedestrian re-ID in noisy environments, a more intuitive solution is to use image enhancement technology for noise reduction. However, there are 2 problems with this solution. One is the risk of loss of details in image enhancement. The other is that the algorithm is too cumbersome to achieve re-ID end-to-end. On the other hand, without proper denoising, the differences between samples are small, which makes conventional triplet metric learning model unable to obtain sufficient discrimination. Therefore, with the knowledge that noise belongs to the high frequency part of the image, we utilize dual domain filtering to reflect the characteristics of image noise combined with triplet metric learning to propose a new triplet construction method. Our model uses the original pedestrian image as a fixed triple, the low frequency image obtained by decomposition as a positive sample, and the high frequency image as a negative sample, which enables the network to learn the distribution of image noise and improve ability of generalizing. Dual domain filtering belongs to transform domain filtering methods. The basic idea is to transform the image into frequency domain, denoise the high frequency part of the image, and then restore it into the spatial domain to generate the denoised image. The combination of bilateral filter and short-time Fourier transform can better preserve the edge, texture, and detail information of the image. And for detail, first, the input image IX is subjected to joint bilateral filtering to obtain the low-frequency image IX wave and the guide layer IG wave. At the first iteration, guide layer is consistent with the input image, and the filtering result will serve as the guide layer for the next iteration. Then perform the short-time Fourier transform to obtain IX wave and IRPG wave, calculate the neighborhood residuals of the input image IX and the guide layer IG at point P, and use the kernel function to perform windowed coefficient contraction. Use IG wave to construct the Gaussian kernel function K wave PF. Combined with IX wave, the model of combined with IX wave, and the model of FP. The model of FP is the number of elements of FP, and the FP itself is the frequency distribution matrix corresponding to IX wave. And this is for the decomposition part. And as for the loss function part, the loss function of the model in this paper mainly includes two parts, the contrast loss and the triplet loss. This paper has made corresponding improvements based on their basic forms. Because the image information contained in low frequency image and the high frequency image obtained by the dual domain filter decomposition is not completely equal. When calculating the loss value with the original image, there will be a certain gap in the value range. Therefore, a weighted factor is added to adjust their relative size. Specifically, after feature calculation by the model in this paper, the feature vector FA of the original image is the fixed image. The feature vector FP of the positive sample is the low frequency image. And the feature vector Fn of the negative sample image is the high frequency image. And the contrast loss is expressed as this formula. Among them, the low frequency graph corresponds to y being equal to 1, and the high frequency part corresponds to y being equal to 0, and w refers to the minimal interval. The triplet loss can make the positive and negative samples from an aggregation effect. It can be expressed as this formula, and among them, w refers to the smallest interval, and the weighting factor mu has the same effect as lambda in the contrast loss. It is a weighted factor and is used to adjust the weights of the two losses in the low frequency graph and the high frequency graph. And now the last page is about the loss, and finally we'll discuss about some model settings. This is the flowchart of the triplet measurement model in the testing and application phases. In model testing, dual domain filtering is not required for denoising. Pedestrian images containing noise are directly inputted into a branch network after training, and the feature vectors of pedestrian small samples are obtained end to end. This is because this decomposition graphs express the distribution of noise well. Thus, the simple feature extraction network can also learn to suppress the image noise. Considering the effects of lighting, posture, angle, view, and occlusion, the order of matching results may not be accurate. So this paper used the K-mutual neighbor or reordering method to expand the ranking table and improves the accuracy of re-identification. Then we'll go into our experiments. Market 5001 and the CHK03 datasets are used for re-identification often, and we adapt the evaluation matrix are rank 1 and MAP as our main metrics. This paper mainly compares 3 types of presentative pedestrian reality methods. They specifically include LOMO plus XQDA, which is a traditional feature extraction method, SpinONet, which is a deep learning feature fusion method, and IDE-ResNet50, which is a reordering method. And in addition, this paper also further compares with the recent deep learning-based algorithms, SVDNet, APR, and PRE. This table lists the results of pedestrian reidentification experiments on this dataset. It can be observed that the MAP of triplet measurement model designed in this paper is superior to most methods in different noise scenarios. The rank 1 is slightly inferior to SVD and APR. The main reason is that this paper mainly adjusts the output structure of the network to adapt to the loss function calculation, which does not specifically improve the accuracy of the model, but focuses more on improving the robustness of the model to noisy scenes. And we'll see more clear in this figures. The figure shows the cumulative matching characteristic curves, or CMC curves, on market 5001, including 3 representative methods. Each color indicates a certain noise condition, and it can be observed that the triplet measurement model proposed in this paper is highly robust in different noise situations, and it can be closest to the performance of pedestrian reidentification in ideal scenes, or the blue line. And similarly, we conduct the experiments on CU-HK03 datasets. And combined with some recent deep learning methods, the performance of these methods still has a certain gap and will further improve the network structure in subsequent studies. We also express our CMC curves on these datasets, and the results show that the CMC curve and MAP index of the triplet measurement model designed in this paper are less attenuated. We can draw the same conclusions like we have on market 5001. And let's conclude our work. That is, in actual power grid surveillance system, it is difficult for many pedestrian reality methods to extract pedestrian features at night, rainy, or foggy days. So focus on pedestrian reality in noisy scene. We propose to use the dual domain filter decomposition to construct triplets, which are used to train machine learning model to learn robust features. Our proposed method mainly consists of 2 parts. First, we analyze the distribution characteristic of image noise in surveillance videos and propose an image denoising method based on dual domain filtering. Second, we draw on the clustering ability of the triplet loss and propose a new way to construct the training triplet. With customized input, our network can further suppress the noise components and improve the robustness of the feature. The experiments on market 5001 and CU-HK03 datasets show that our robustness to the noise, and our rank 1 only drops around 1% in noisy scene, which means the proposed methods can make the accuracy of noisy pedestrian reality performance be close to that in non-noisy environment. And that's all for my presentation. Thank you.
Thank you very much. And I have a question. What are the limitations of suggested methods by you?
Limitations. Maybe I should share my screen again. So we talk about it in the second data sets. Actually, we have mentioned that compared with some recent deep learning methods, although we achieve comparable results on market 5001, the results on CU-HK03, we still have a clear gap. And we have discussed it about because our methods don't focus directly on the accuracy. But we also say that though this method is not a very high accuracy model, but we think our idea and our methods or approach of metric learning, triplet metric learning can adapt to these methods and improve. I think we maybe can improve their accuracy under noisy scene, and maybe that's all.
Okay, thank you. Thank you for your presentation. Any questions?
Yeah, probably one from me.
Okay, okay.
Thanks a lot. Your paper is highly topical, and so the question is, have you tried to use some other backbone for your system except ResNet 50?
Yes, I think, so sorry. I mean, that's obviously a very constructive mention, but it's just due to some time limitations that we don't have time to experiment with some other backbones like ResNet 101 or the newest transformers. So I think in later work, it will be we'll consider it. Thank you.
And how long does it usually take you to provide your experiment,
Usually provide the experiments. I'm afraid I can't recall it now. Do you mean that?
Well, just hours, days. So like, I don't need like specifically seconds.
I think it's about one or 2 days, maybe.
Okay, thank you.
Okay, thank you.
Okay, thank you. The next presentation is performance analysis of free text keystroke. Yes. Okay. Speaker is absent. Cyberbullying detection and classification in social media text using machine learning techniques. Okay.
I'm here.
Detection. Oh. Yes. You can share screen.
Okay, thank you.
Have your time. Okay.
Chair, before this presentation starts, we are here for the 11:15 presentation. The XGBoost will present as scheduled, if that's okay.
Okay, you will be next. Sorry.
I don't know, is the slide visible?
It's okay.
Is it on slideshow? It's on slideshow. Okay.
Okay.
Hello, everyone. First of all, I want to thank the organizers of this event for inviting me to present our research work on cyberbullying detection and classification in social media text using machine learning techniques. I'm one of the authors, and the other authors are Joseph Akinyemi, Ayodeji Bitoye, Olufade Onifade, and myself, Christiana Oyewale. So, due to easy access to internet, which connects people from different sides of the world, people from different background, ages, race, ethnicity, and the like. It has made social media platforms like Snapchat, TikTok, Twitter, Facebook, and the like to be rampant in usage. So bullying, which can be carried out physically or verbally, where the victim is being threatened first, under compulsion, which leads to being maltreated, intimidated, overpowers, and the like. This bullying has found its way to social media, and it's being carried out using electronic devices, which are smartphones, computer, and the like. So cyberbullying is sending, posting, or sharing negative, harmful, false, or mean content about someone else, which can be in textual form, audio, videos, and images. So before the time of technology and internet, investigations on bullying has been in existence for about 40 years, but finding its way to the social media has made research to go into creating a model that automatically identify the instances of cyberbullying on social networks. And part of the research done is making use of numbers of machine learning algorithms, like support vector machine to predict, for example, hate speech in tweets, which achieve an accuracy of 53% for the third research that is being displayed on this slide. So having research go into identification of cyberbullying on social media, different research like analysis, different research were performed on analysis to compare classification of algorithm, and part of the machine learning algorithm that were used, naive-Bayes decision tree, logistic regression, support vector machine for detecting cyberbullying crime using, for example, the Indonesia Twitter social media. Yes, internet technology, social media has a lot of advantages, but the few disadvantages outweighs the advantages, because the victim that is being bullied, it's caused different negative effects on them. For example, it can lead to depression, fear, anxiety, even the victim can commit suicide. This became a public health and emotional problem. And there's a need to combat this problem. So recently, AI emerged as a solution to cyberbullying, and it outshined many earlier solutions. So investigating the problem of cyberbullying on social media platform using deep learning, machine learning, and even natural language processing technique. Not just classification. In this research, we are not just classifying cyberbullying to be, classifying this text to be cyberbullying or not cyberbullying, but we further classified into age-based, religion, ethnic, political cyberbullying, or non-cyberbullying. A tweet like the one displayed in this slide was being pre-processed by cleaning it, tokenizing, padding, and the like. So extracting the necessary words were passed to word embeddings, and word embeddings converted them to their equivalent vectors, which was passed into classifiers. In this case, we made use of 5 machine learning classifiers, which are gradient boosting, logistic regression, naive Bayes, random forest, and for support vector machine. But for deep learning, we made use of bidirectional long short-term memory. So this classifier gave their outputs of having 5 classification, which that's age, ethnicity, gender, religion, and not cyberbullying. The data set for this research was was gotten from Twitter, and using scikit-learn to split 47,692 tweets into 80% data set for training and 20% for testing. So the tweets was pre-processed by, sorry about that. Sorry, I'm trying to go back. Okay. The tweets was pre-processed by removing the hash, some other things. After pre-processing, it became cleaned and was used for the classification. So after performing these 6 experiments, random forests had 93%. It's outperformed the other 5. Naive Bayes performed worst, which had 84%, and deep learning, the only deep learning model that was used had 91%. So for the training and validation loss and accuracy for the deep learning model that was used, as the epoch increases, the loss decreases, but at 7th epoch, the training and loss and validation loss met at the 7th epoch. For the accuracy, as the epoch increase, the accuracy increases and met at the 6th epoch. Yes, social media brought a lot of advantages to us, and the more people stay on the internet, the more data is being generated. But having cyberbullying finding its way to the internet, there's a need to combat cyberbullying. In this research, we made use of 5 machine learning models and 1 deep learning model. And for the feature vector, we made use of T-IDF, which is term frequency inverse document frequency, having 5,000 dimensional, and GLOVE, which is global vectors for word representation. In this research, random forests had the best performance, while naive Bayes had the worst performance. In the future, we are considering having more feature representation scheme, more hyperparameter tuning scheme, in order to obtain optimal settings for improved performance on larger cyberbullying data sets. These are the sample references. Thank you for listening.
Thank you. Questions?
There is a question in the chat.
Yes.
Could you please tell in your own words, what's the novelty of your study? How does it differ from existing ones? Thanks.
Can you come again?
What's the novelty of your study and how is it different from the existing ones? Existing ones, yep.
Okay, yes, I get you. From the literature, I'm trying to go back to the literature review. Different literatures were actually reviewed in this study, and the research work that we extended from had an accuracy of I'm trying to remember the accuracy that the literature I think had the accuracy less than 80%, but we are able to, using the same data set, we are able to achieve an accuracy of 93%.
Okay, thank you.
And
Some questions?
Could I also have a question for you? I suppose that in your case, you have like a binary classification task, but have you ever considered like the case of multi-class classification, like not just Boolean, non-Boolean classes, but also like, I don't know, some insult, humiliation, whatever, some additional groups for classification? And could your method be somehow applicable to these cases?
Yes, we didn't do binary classification. The classification were 5. And I think this also answers your previous question, because from our research, most classification in this regard were binary, but we extended to having a multi-class. That's, we classified into 5. That's based on the age, religion, ethnic, and what's the 4th one? Then the 5th one is the 4th is gender. Then the 5th one is non-cyberbullying.
No,
I don't know.
I mean the resulting classification groups, like you have like Boolean and non-Boolean classes. So definitely there are just 2 groups. But I wanted just to ask you about the case if you have more resulting groups like Boolean, non-Boolean, and some in-between groups, like, I don't know, some sort of Boolean, but like some softer versions, you know what I mean? I was asking about such cases. I do understand that you have analyzed different classes like age, ethnicity, gender, religion, accuracy, whatever. But I mean about the resulting classes, the resulting groups.
Okay, I don't actually get you, but if I understand the question, that's doing a binary classification, those that has cyberbullying were now furtherly classified to based on the age, the ethnicity, gender, religion. I don't know if
thank you.
that
And we have
answers
one more question from the chat. What did you do to improve to achieve the better accuracy? What did you do to achieve the better accuracy rates?
But for the presenter, which is unavoidably absent, supposed to take this presentation, is the one that actually worked more on improving the model. But from my understanding of what he did a lot of parameter tuning, and like the research that made use of this particular data set made use of more than 5,000 dimension for TF-IDF, but during the training, it slowed down the training. So we had to start by using from 2,000 dimension, and we're able to get a good accuracy using 5,000 dimension.
Okay, thank you so much.
Okay, thank you. The next presentation is detection of potential mosquito breeding sites using CNN and few short learning.
Hi, Chair. Can I do the 11:15 one now? Is that okay?
Okay, it's okay.
Perfect.
If you are
Let's do that then. Excellent.
okay.
I'll share my screen. Right.
Yes, I'm stop sharing. Okay.
Hope everybody can hear me. Good
Yes.
morning. My name is Bogdan Gita. I'm from University of Plymouth, and I'm going to talk to you about a paper that very good student, worked on very hard for a whole year. Saransh did an excellent job on performance analysis of pretext keystroke authentication using XGBoost. So I should mention a bit of more background. So Saransh did the work under the supervision of Yevgenia, who's also in the session, and I helped a little bit towards the end, and I'm helping today with the presentation as well. So let's start with an overview. So I'll discuss a little bit about the context. It's worth, although we are in a session talking quite a bit about cybersecurity, cyber and authentication and so on, I'll revisit a bit of the issues. We'll talk about the proposed solution, a little bit about the implementation. Of course, we'll discuss about the results and a quick analysis at the end and conclusions. Okay, so let's talk a bit about the context. So we've got the issue of computing. We're already moving from the era where we had computers on our desks. We're connecting directly. Physical security was the main option, if you want. Basically, we've got from local hardware at the moment all the way to remote access in the cloud. And we've got, together with it, a variable delay, occasional packet loss, so all sorts of issues happening with it. Now, coming to authentication, we're all used to username and password, and we started slowly moving towards biometrics. The preferred biometrics would be to be based on fixed text, and it shouldn't be continuous. So what we're seeing more and more is moving from traditional username and password towards monitoring the way we type based on a fixed text. So you would get a fixed phrase, whatever the phrase is, then the analysis will be done on that fixed phrase. And of course, that would not be continuous. Now, the problem is that security as users, so leave aside yourselves as researchers, think of yourselves as users, is expected to be continuous and transparent. So you should have a minimal use of passwords, a free text input, and continuous reevaluation of the user. Why? Because we wouldn't like to be exposed every 10 minutes with the same, please type this phrase, or please type this password, or re-enter your password, or every 3 months, change your password, and so on. So what has been done? Well, fortunately, unfortunately, whichever way you want to see it, most of the prior research was focused on dynamics of fixed text. Why? Because it's easier to categorize. You don't have so much variability as in free text. So you have a specific sequence of events that you can feed a lot easier to machine learning. And the parameters relatively constant over time, especially if that phrase becomes a bit automated. You, as a user, tend to type it the same way, very differently from other users. So it's really relying on sequence rather than statistics. It's not about how you type text throughout. It's about how you type that specific text. What's the problem with it? It cannot be continuous. It cannot be transparent. You'd have a prompt, please type this text now. You enter the text again, 5-10 minutes later, you type the text again. What's the further problem? You type the text, then you move away from the terminal, then somebody else can take over it and can start using it until the prompt comes up again. There are plenty of fusion options out there, and the easiest one, everybody goes back to fingerprint for enrollment whenever biometrics don't work that well. So yes, we have always the fingerprint with a relatively high accuracy that we can go back to, but again, we want transparency, and the typical accuracy for the prior research is around 90%, which is not bad, particularly when you build in other methods to secure it. So what do you want Saransh to do? Basically, to investigate the applicability of free text for biometric authentication with applying additional activity-based characteristics. We know there was plenty of work being done in the area, but we wanted a bit more play, a bit more research into what more can we do to actually provide a good accuracy. What did we have in mind? We had transparency in mind and no fixed text and continuous authentication. So this process goes on in the background and it picks up whenever biometrics start veering too much. It will bring up more authentication methods to actually ensure that the user is who they say they are. What's different, as in most studies, you can have two things that are different, either the algorithm or the features. We use an algorithm that was used by other research as well, but we slightly tweaked the features because we rely on physical characteristics rather than digraphs. So we used XGBoost, which was used by quite a few papers before. It was a good choice, highlighted by previous research. It was mostly used in previous research as a fixed text and mostly used for digraphs. But what we did an aggregation of data over 10 minutes and to identify the user. Bear in mind, this is not entry authentication. This is continuous background authentication. So it's suitable if you think every 10 minutes you want to detect, to determine whether that user is still the correct one. This is the, I shouldn't say perfect, but it's a good alternative, okay? Right, so let's move on to the features. Why did we use these features? And we use very wide, very, how should I put it, very aggregated features. So we looked at the hold time of keys on the left part without shift, hold time at the keys right part without the shift, the same with shift, plus hold time of space key and hold time of backspace key. I mean, the space and backspace, I'm just looking at my keyboard and I'm looking the way it shines. You've got a very specific ways, each user has got very specific ways of typing the backspace and the space key. So this is why it came up. And of course, sometimes we make errors. Every time we need to separate between words, you need to press the space key. So it was very useful to integrate these, very intuitive, I should say, to integrate these. Looking at, just briefly, if you have a look at the table, we have a quick example of what a sample would look like. So a couple of users, there's user 1 and user 10, collected data over time. And sometimes, as you can see with the backspace, if they don't make any errors, you wouldn't have any data recorded. So it would be a 0 in there. Okay, so quickly implementation, nothing out of the ordinary with this. We used the Clarkson dataset too, which is used by quite a few of the other studies. We did a bit of pre-processing. The pre-processed dataset was run through a process of feature extraction. Then feature extraction CSV was split into a 80-20 training and testing data, then run through the XGBoost model, evaluation performance analysis, and we got the result. Okay, so what were the results? We have a look. It's interesting because ultimately, instead of focusing the analysis, focusing the discrimination on the actual keys, somehow the model picked up the spacebar and the backspace as a higher importance. So we've got them being discriminated, being the highest discriminator, so it's the highest importance for those. Also, the left hand and the right hand with and without shift contributed, but to a lesser extent. So as we can see, the left and right hand with shift were the lowest contributors, then the ones without shift, the lower case, and then the space bar and backspace. So just briefly to mention the data set, just in case maybe some of you haven't heard of it, haven't used it, is the Clarkson University's data set. So it's Clarkson 2 data set. Feel free to use it. It's convenient. It's if you want it, it goes back to the KDD and DARPA sets that we established in the beginning of IDS to do intrusion detection, to test attacks. Okay, so let's see the results. And I know normally you would want to see a first diagonal, but because of the way we organized users against identified users, we've got a second diagonal. Anyway, you can see it's the prediction is almost perfect. I should say that, shouldn't I? But we've got a 92% accuracy, and for 79 users, you can see virtually all the users were with a few gaps in there were correctly identified. So it worked. Basically, we got a very good result, and we were successful in discriminating all the users in the data set just based on these aggregated features. So to conclude, I think it's a bit strong to say a new approach for continuous biometric authentication, but ultimately we got a novel set of features and we run it on free text, which is something that most biometric studies try to shy away from because it's a bit more difficult to apply. And I would say, although we haven't done it yet, it's quite effective for a transparent process. So it's not as accurate as fixed text, fair enough, and may require reauthentication due to false negatives, but nevertheless, it's a process that we can run in the background in addition to whatever authentication we have. And it's particularly good in cases where you may have intruders come in the middle of the session. So imagine a remote access where you have a man in the middle attack, or a multi-user area where the authenticated user may step away from the screen and a malicious user may start using the machine. So for these types of cases, it's very useful to have a method like this in the background, even though it might have slightly lower accuracy, but it would be able to pick up whenever an intruder joins in. And that's the end of my presentation. Thank you.
Thank you very much for really a good research result. So question, I think participants have a question.
Yeah, probably one for me in this case. Thanks a lot for quite an interesting talk. I'm just curious, I suppose your method is applicable just to a keyboard, right? But what if we have like a smartphone, and like, what if a person keeps on typing in some information using just fingers? I mean, like maybe one hand, a couple of fingers. I mean, do you have any ideas how your methods would be applied to this case?
Thank you, Alexei. That's a very good question. I mean, unfortunately, the Clarkson dataset only had keyboard-based entries. So by all means, a very good option for research and plenty of citations, I should imagine, would be from a dataset developed from a mobile terminal, which I fully agree with you would have very different characteristics from a keyboard. But this was what we had available. So yes, by all means, it would be very interesting. And I think it'd be something that we would all want to see. I haven't seen them yet in the literature. Hopefully in the years to come, somebody will decide to build up a similar data set. So yeah, very good question. Once the data set is there, we'll reapply the method to it.
Thank you so much for a great talk.
Thank you.
Okay, thank you. Dear participants, we work out of schedule, so maybe some of you can represent earlier presentation. Okay. If you want, the next presentation is detection of potential mosquito breeding site using CNN and few learning. Are you there?
Yeah, yes, ma'am. Yeah.
Okay, have your time. Okay, we see this presentation.
Hello, everyone. First of all, I would like to thank the organizers for inviting us today. Let me introduce myself. My name is Niluksha from University of Peradeniya. Today, I am pleased to present a paper that I have co-authored. My co-authors are Gabalini Ananda Jyoti, Rukshika Navaratnam, and Mayazi Disanaika. Our research explores detection of potential mosquito breeding sites using convolutional neural network and few-shot learning. As a brief introduction of our research, dengue fever is a viral infection affecting millions of people yearly in tropical and subtropical countries. The Aedes mosquito transmit the virus thrives in areas with standing water, which difficult for public health inspector to physically check every potential sites for the presence of mosquito vectors. It is possible to remotely identify potential mosquito breeding sites with stagnant water that are inaccessible to the human observer using drone cameras and visual inspection. But our approach utilizes a supervised learning approach, specifically few-shot learning and shallow convolutional neural network to automatically detect objects and location with high potential to become mosquito breeding sites using aerial images. Let's move to the literature review. The literature review highlights the emergence of computer vision-based solutions with self-learning capabilities in recent years. Most of the literature on this topic mainly utilizes visual inspection or image processing techniques to detect water. Recent literature attempts to automate this process using machine learning and deep learning approaches. For instance, deep learning-based image segmentation methods are compared for the task of automated segmentation of water regions in aerial images. In our work, we use few-shot learning and shallow convolutional neural network to provide an intelligent solution to address the limitations of earlier works. Let's briefly discuss about convolutional neural network. Convolutional neural network has become one of the most shortcut algorithm in deep learning, especially in computer vision, to solve technically challenging problems. They can deliver high performance in analytical tasks without human intervention. This multi-layer model automatically extracts features from input images using convolutional operation and learn patterns for the classifier using neuron with hidden layers. A deep convolutional neural network consists of millions of trainable parameters requiring a significantly larger data set for promising performance. This diagram shows the concept of convolutional neural network. When we discuss about the few-shot learning is a popular deep learning technique which is used when training data are either hard to find or costly to generate. This few-shot concept can be used for training the model with a lower amount of data. Few-shot learning does not explicitly train the model to recognize the input image class, but instead use the knowledge learned at testing. Few-shot learning model consists of a support set and a query set. The few-shot learning model learns from the support set and evaluate the performance of the query set, which the model has never seen before. This diagram shows the concept of few-shot learning. When we come to the methodology, first thing is the data set. We custom created a data set using aerial images captured by drone cameras of different models and resolution. The data set consists of 347 images representing the with water and without water classes. Then we resize the input image to 256 into 256 during the model training. For convolutional neural network model, we split the data set into training, validation, and testing sets with 60:20:20 ratio, with the data set shuffled before splitting. Likewise, For future learning, we used 20 samples per class as the support set, whereas the query set consisted of 5 images per single iteration. Next one is the learning model. Initially, input the image to the image and then pre-process it. After that, feed the pre-processed data to the deep learning model and finally get the classified data as the output from the model. Here we used convolutional neural network and future learning models as deep learning models. The sequential convolutional neural network model constructed is given here. The model consists of 7 trainable layers with a breakdown of 5 convolutional layers and 2 fully connected layers. Each convolutional layer is separated by a max pooling layer, while the input to the model is a 256 into 256 RGB image. The model adapts sigmoid activation, ADAM optimizer with adaptive learning rate. The dropout layer with 0.3 helped to prevent overfitting. The model was trained over 100 epochs with batch size of 16. Finally, the trained model was tested using test data which never seen before. For the implementation of future learning model, we specifically use future learning model with reptile algorithm, which has the capacity to learn quickly as well as to classify new tasks with minimal training. The implementation is nearly identical to the original implementation by A.D. Moreau with few modifications to meet the specific requirement. This table shows the fine-tuned parameter used as the final implementation. Let's see the results. For the convolutional neural network model, model-based classification of presence and absence of water in the input aerial image, the trained model show a training accuracy of 97.47% and testing accuracy of 84.29%. This figure shows the training and testing accuracy as well as the loss for over 100 training epochs. These are some selected images of convolutional neural network model along with the predicted class and the probability value for each image. Since our model is a binary classifier, the prediction will be flowed between 0 and 1, representing the probability of samples belong to the positive class. The detection probability value 0 indicates that the input image belongs to presence of water, while the 1 indicates absence of water in the aerial images. This graph shows the training and testing accuracy of future learning model. This model showed improved performance in terms of classification accuracy. The maximum accuracy observed at the training and testing at 2000 epochs in the average around 80%. These are some output results of future learning. Here 0 indicates the presence of water and 1 indicates the absence of water. Since the first figure label and prediction are 0, this image correctly detected as with water. Second figure also correctly detected as without water. Since the third image label and prediction are different, therefore that image incorrectly detected. This table shows the comparison for convolutional neural network and future learning based on the parameters such as accuracy, precision, recall, and F1 score. These parameters calculated using the predicted and actual label value. With this observation, we may get a decision as shallow convolutional neural network model perform better than future learning model. When come to the conclusion, the primary goal of the research is develop an automated system for detecting water areas in inaccessible locations for humans. For this purpose, we proposed shallow convolutional neural network and future learning as potential learning methods, as they have shown promising performance with smaller data set. Overall, the shallow convolutional neural network model outperformed the featured learning model for the given task with an accuracy improvement of 5.29% at testing. We conclude that shallow convolutional neural network is better than featured learning for the task of detecting the presence of water in aerial images. It is possible to train a deep learning model from scratch using a smaller data set to meet task-specific applications. That's all about our research. Thank you.
Okay, thank you. Any questions? Some participants, have you any questions?
Yes, I have a question. Could you please show the table with the results? I guess it's slide 14. 14. Yeah, this one.
Okay.
In your conclusions, you say that the net improvement of accuracy is 5.29% or something like that. But
Yes.
can we consider error of recognition? Say the error was 20%, and then it became 14.71. And can we compare this decrease of error?
So I didn't get the last point.
So can we consider not the increase of accuracy, but the decrease of error? I mean, if, here you have the criterion accuracy as the criterion, but what if we consider the error as the criterion for characterizing performance of the proposed method?
We would choose featured learning as better one if we want to consider the false detection.
Yeah. Because actually increased accuracy means decreased faulty detections.
Yes.
And in this case, your figures of improvement will be, how to say, more picturesque, because faulty detection is about 20% here, but fall of 5% means fault of the faulty detections by 25% or something like that.
Oh, that one we compared the both deep learning models. That means the convolutional neural network overperformed to the future learning 5.929%. That's what I said.
Okay, thank you.
Thank you.
Thank you.
Can I stop share?
Okay, the next paper is number 2365, special temporal graph neural network based anomaly detection.
Yeah, here.
Okay. Please share the screen. Okay. We will see. You can start.
Do you see?
We see your desktop. Okay. We see. You show a desktop. Okay. We don't hear you.
Oh,
You have some technical issue?
do you hear?
Yeah. And see your presentation. You can start.
Oh, okay.
Now we can see. You can try again. Share.
Okay, okay.
Hello everyone, it is my pleasure to share our research work on a framework for multivariate time series anomaly detection. With the development and advancement of technology, a large number of devices and systems generate a wide range of time series data. Those data may contain anomalous values, which can lead to equipment failures and production stoppages, if not detected and handled in a timely manner. Therefore, multivariate time series anomaly detection has become one of the urgent problem to be solved. A time series records data points that are one-valued variable, each of which models one channel of time series. If the data point consists of only one variable, then the time series is referred to as a univariate time series. Otherwise, a multivariate time series. The current mainstream time series anomaly detection methods can be divided into prediction-based methods and reconstruction-based methods. In this paper, we use the prediction-based approach for anomaly detection of multivariate time series. The production-based approach uses a learned model to predict multiple time steps of the current window. The predicted values depend entirely on the data from the previous window of the time series and the learned model. The predicted values are then compared to the observed values to determine the size of the error. If the error is greater than a given threshold, it is determined to be an outlier. The main difference between different methods lies in the type of prediction model used, and their mainstream methods currently include the long, short-term memory network and HTM, ESN, and GNN. Yeah. Since numerous data represent only a small fraction of the whole, in existing prediction-based anomaly detection methods, they usually assume that the training data include only normal data, while it can't not be ignored that those anomalous data still increase the unpredictability of the training data. Therefore, we expect that the model should ignore the abnormal fluctuations in the training data as much as possible. Time series is a special type of serial data that has features that other types of serial data don't have. Trained seasonality, and the proper use of those two features can help us to be able to make normal predictions. Existing deep learning techniques use generic serial models to model temporal correlations and ignore their unusual features. First, we propose a pre-training scheme for multivariate time series. The negative effects of numerous fluctuations in their training data are weakened by learning a dense vector representation of the time series data based on improved transformer encoder. Second, based on the unique characteristics of time series, we propose an interactive tree structure that can learn representations with high predictability by iteratively extracting and in exchanging information at different temporal resolutions. Finally, we design an interactive spatial temporal graph nature network for multivariate time series prediction, which studies the inter-feature dependence and dependent on timing of multivariate time series respectively from their future dimension and time dimension. Our model consists of a pre-training model and a prediction model. Among them, the pre-training model use unlabeled data for repetition learning of multivariate time series based on the transformer encoder, which aims to attenuate the effects of numerous fluctuations in the training data. The The prediction model attempts to model the correlation between different sensors while modeling the temporal dependence within each time series. We treat each univariate time series as a separate feature, construct fully connected GNSS matrices across all sensors, and then learn the correlations between all sensors via JTV2. To better exploit the unique properties of time series, we construct an interactivity tree structure based on temporal convolution, which not only achieves a large field of sensors, but also avoids the limitation of TCN's ability to extract temporal dynamic only from the features of previous layer. The natural advantage of the tree structure can propagate the information from the upper layer will gradually accumulate downward to learn the hidden temporal dependence from the long-term and short-term dependence. MSL and SMAP are spacecraft datasets collected and published by NASA, each with a training subset and a test subset, and both test subsets have for labeled files in which all anomaly are labeled. SMD is an application server dataset and is the largest public dataset available for performing evolution of multivariate time series anomaly detection. In order to verify the effectiveness of the detection model proposed in this paper, type protocol detection model shown in the table was selected as a comparison method. It can be seen from the table. The model in this paper has a more excellent generalization ability and advanced the best score on all datasets, which is beyond the comparison of other baselines. Through this study, we have successfully proposed a multivariate time series anomaly detection framework, which is important for solving problems in multivariate time series anomaly detection. Looking ahead, we believe the framework can be further improved and enhanced to meet the needs of different real-world application cases. We will continue our efforts to promote research in this area and make greater contributions to achieve more smart and efficient anomaly detection services. Finally, I would like to thank the paper reviewers and conference organizers for their support and assistance, and the audience for listening and paying attention. Thank you.
Thank you very much.
Thank you for your listening.
Questions?
Probably I
Alexei?
will. Yeah. If
Okay.
no one, if no one objects, so what pre-processing steps have you taken during your experimental support? I mean, probably you haven't covered this topic in detail during your speech, so probably could you please specify this aspect?
Please take again.
Pre-processing of your time series. I mean, just what's given as an input to your system.
Okay.
Maybe network data site, floor, port features.
Yeah, but have you pre-processed it somehow before you feed it to a neural network?
We will first we witness the Earth's effects of the normally in the training data through the pre-training strategy, so that that model can better learning the normal pattern of time series. Secondly, starting from the future of time series and interactive tree structure are used to learn the dependence between future and time dependence respectively.
Okay, thank you.
Thank you.
Okay, thank you. The next speaker is paper ID 2099, development and application of ship log system simulation model library. Okay, is that awesome? The next is 2431 hardware modifier addictive Fibonacci generators using prime numbers.
Yes, I'm here. I can start my presentation.
Super.
Can you see my screen?
Yes, we see.
One moment, please.
You can start. Thank you.
One moment, but unfortunately, if you do not mind, I will use this view instead of the full screen view.
Okay, it's perfect.
Okay, so now let's start. I'd like to introduce my report entitled Hardware Modified Additive Fibonacci Generators Using Prime Numbers. So currently, the pseudo-random bit sequence generator are used for information protection, providing cybersecurity for computer networks, for forecasting in computer games, and in many other areas. As a result of such popularity, new and more refined demands for their quality appear. so for instance, their random sequences should be as close as possible to truly random sequences. They should pass the most statistical tests, have maximum possible repetition period, be unpredictable and resistant to non-attacks. Also, they should be fast enough, simple enough for in both software and hardware implementations, to be able to solve the task of practice. So the goal of this paper is to develop and investigate characteristics of new basic structure of modified additive Fibonacci generators. Henceforth, they will be abbreviated as MAFG, which differ from the classic additive Fibonacci generator because the proposed solution can operate with an arbitrary module of the recurrent equation. And for instance, this module in this particular case is a prime number. And this the proposed generator allows significantly improve characteristics of pseudo-random sequence generators of this type. So now let's consider their structure. Here we see the basic structure of the additive Fibonacci generator, whose work can be described using this equation. This circuit consists of 3 registers, 1, 2, and 3, 2 summers, and 1 logical gate. In this particular, this is the OR gate. Also, it consists of 1 multiplexer. On the right-hand side, we show the proposed circuit. This circuit is basically the same, but it is its structure is improved by this logical circuit has additional component which improves the random nature of the generated numbers, generated sequences of numbers, random numbers, and the further works, further presentation is dedicated to comparison of this basic structure and the proposed one. We developed one is the abstract model, which is used to study characteristics of generators with large numbers, irrespectively of their hardware implementation. This considerably reduces the time of studies, and also the hardware models. It allows us to study hardware implementation of the generators. For instance, when they are implemented in the base crystal of ICs, integrated circuits. And the studies will show whether this improvement is effective or not. So AFG, like any cryptographic pseudorandom sequence generators, use arguments whose values are very large. That is why certain problems in the procedure of determining their statistical characteristics appear. For both versions of generators, we created two models. One was the abstract model, and the second one was the hardware model. Abstract model is independent from the scheme design, so performance of elements do not influence. It's just the basic idea is studied in this model, and the hardware model, in hardware model, we implementation of the structure. In this slide, we can see the algorithm of the hardware model. Pay attention at this equation. In this case, mod 2 to the power n is considered, where n is the number of binary bits of the generator. The abstract model of version 1 operates using the following expressions. In this case, number m is can be arbitrary one, but in this particular paper, we studied prime numbers. So results of studies are presented in this slide. Here we can see the dependencies of pseudorandom numbers formed by additive Fibonacci generators, version 1. Here we see that the hardware model and the abstract model are give identical results, and their repetition periods are also identical. So the theory and practice have commensurable results. They virtually coincide. It shows that the studies are legitimate and their results are significant. So these are pseudorandom numbers, and these are repetition periods. As it was mentioned above, they are identical. And this is the proposed structure of modified additive Fibonacci generators. As it was mentioned above, we add this circuit to improve the properties. The following expressions explain its operation. Here we see the hardware model we consider here and the abstract model. As it was mentioned earlier, m can be any number, but we used prime numbers in this particular study. And here we have the results of our studies. Here we can see that the generated numbers are identical. So the theory and practice are give convergent results. And also we see that the repetition period for both models is identical. Also, we need to estimate statistical characteristics of the proposed generators using the known methodology. developed by NIST in the United States, which consists of 15 statistical tests in testing process. And we calculated 188 values to test, and the results of testing are presented here on these plots and also here in this table. As you can see, the proposed generator passed all the tests, unlike to its basic version. It failed to pass some tests, almost 50% of tests it failed to pass. That is why our improvement is significant, and it provides a considerable improvement of the proposed generator. Also, we can conclude that this paper proposed a new method of improving characteristics of modified additive Fibonacci generators, whose work is based on recurrent equations with arbitrary models. Our improvement, one moment, please. Our improvement shows good results and managed to pass all statistical tests for known technique developed by the NIST. So this is the end of my presentation. Thank you for your attention.
Thank you for good research presentation. And have you a question, dear participant? Okay, I have a question. What are the advantages of using prime numbers in the modified additive Fibonacci generators methods? What disadvantages of your methods?
Advantages, these generators are robust to attacks. They are less predictable than their competitors, but also their hardware implementation is easier than for the competing methods.
Okay, thank you.
Thank you.
We will find the next speakers. The next paper is paper ID 2433, data acquisition system for monitoring soil parameters.
Yes, I'm here.
Okay.
Let me share my screen.
Have a time. Okay.
It's visible?
Yes.
Okay,
Please.
great. Hi, dear colleagues. First of all, I would like to thank the organizer for inviting me. Let me introduce myself shortly. My name is Tatiana Fedyshin from Lviv Polytechnic National University in Ukraine. My co-authors are Tatiana Bubella, Irina Petrovska, and Christopher Prestupa. Today, I would like to present our research data acquisition system for monitoring soil parameters. The purpose of the study is creating a data acquisition system for cyber-physical system, which contains channel for measuring such important soil parameters as humidity, temperature, acidity, and density. Because monitoring of soil parameters is important for farmers to make the right management decision. This is especially useful for small farms, where the farmer needs to have up-to-date information about the condition of his land. Also, it is important to choose the correct dates for sowing seeds and harvesting. Therefore, the authors propose to implement a neural network in a cyber-physical system. In order to provide objective information and make the right decision, soil monitoring should provide initial, current, and periodical data of the main characteristic of the soil cover. Mandatory evaluation criteria are granulometric and mineralogical composition, data on the humus state of the soil, evaluation data on the formation of soil regimes. The analysis shows that the following main influencing factor on soil characteristic can be identified, and it's present on the slide. I would like to give you an overview to characterization of the thermal regime of the soil. The question's influence of soil temperature on plant growth in the context of global climate change is even more relevant, which simulates the growing interest scientific in studying the mathematics and influence of soil temperature on plants ecosystem. The main factors influencing the temperature of the soil in solar insolation, which depends on the geographic location, exposure of area, season, and the presence of clouds. Therefore, soil temperature is one of the determining factors affecting plant nutrition, which should not be underestimated when creating a monitoring system. Modern achievements, the displaying of the essence of many biological phenomena and the development of control methods make it possible to adjust the process of crop formation and product quality. In order to monitor the condition of soil, a data acquisition system is proposed, which is a part of cyber-physical system. Time series prediction is considered to be one of the most widely used methods in data science, used in various industries such as finance, supply chain management, manufacturing, and inventory planning. Test and train partition involves a model's validation produced that allows you to simulate how the model will perform on new unknown data. Here is shown the produced work as you see on screen. At the current stage, the most advanced modeling concepts are used to build predictive models, methods of fractal and intelligent analysis of system evolution, fuzzy logic tools, and artificial neural networks. In other words, the forecast established the potential of growing crops in specific soil and climatic condition, and the program realized the potential of the forecast through management. The task of soil monitoring is to control the dynamic, the main physical, chemical, biological, and other soil processes under neural condition and anthropogenic loads. For objective information support and correct decision-making, soil monitoring should provide initial, current, and periodical data of the main characteristic of the soil cover. The considered research and monitoring have shown the high efficacy of using artificial neural network model for long-term forecasting of non-stationary random process on the example of winter white year. The optional version of predicted model is shown on the slide. In order to adapt the generalized structure of cyber-physical system to task of managing grain production, is it divided into subtasks, which the preparation of agricultural land for showing production process, certification of product of such production. For each of the levels for cyber-physical systems, the structure element will undergo certain modification, but the unification of requirements for them will be ensured both at the level of the object of study, soil, water, air, and in relation to the finished product. In general, to build the cyber-physical system of grain production, the main stage of his process are structured, at each of which the cyber-physical system will make decision necessary to perform contained management action to optimize this process. The next steps involve making decision about the amount of fertilizer applied, the readiness of the crop of sowing, and the calculation of mass rate of sowing. At the final stage, the cyber-physical system will give instruction on how to harvest to crop correctly, depending on its degree of readiness by processing of measuring data. Reliability to precision of results ensured by the use of verified measuring instrument, multiple repeated measurement of main soil parameters. In addition, the uncertainty budget for the measurement of humidity, it's table 1, and temperature, it's table 2. Acidity and density was calculated for the development management data collection system. The source of uncertainty in the management of the main solar characteristic was identified. For the next part of research work was implemented software. Mobile devices have long been an excellent reliable addition for exotic management tools, and in some places have replaced a PC. If we take the example for precise mobile devices allow you to avoid being tied to your workplace. That is why it was explained to develop a mobile application for Android and iOS, which will become indispensable in solving the problem of agriculture production control. By installing the mobile version of application on smartphone, tablet, or device running Android or iOS, user will be able to control all production process, view them separately, and receive recommendation at each stage of production. Let me summarize the information. The result of this investigation in the development of a data acquisition system for cyber-physical monitoring of soil parameters in the form of mobile application running on Android and iOS. In order to identify the most important monitoring parameter and analyze the study of the influence factor of soil condition was conducted, and a list of them was established, namely, and the main one include humidity, temperature, acidity, and density. Established the relevance of the creation of cyber-physical system for monitoring the condition of soil during the implementation of agriculture process. Thank you for attention.
Thank you. I have a question. Tatiana, could you tell me how does the data acquisition system collect and store data?
We created the collection system, measurement system, and after that collected data sent to cloud and to our application.
Okay, thank you.
I have a few questions.
Yeah.
Okay, you used two terms, one data acquisition system and data collection system. Do you mean the same in these both cases or no?
Yeah.
Okay, so next question. Suppose you have sensors and they operate for some time. How do you ensure their meteorological reliability? Do you have any procedures for calibrating or no?
Yeah. We have calibrating and we have budget of uncertainty.
Yeah, but how do you calibrate, for instance, the temperature sensor? semiconductors. As far as I understand, you use some semiconductor temperature sensors.
Yeah.
They are not very stable. How do you calibrate them?
We have for the same system, and we calibrate for some. We are measuring summary for data, and after that we calibrate system.
How often do you calibrate, for instance, the temperature sensor?
1.5 years.
Once a half year. Okay, thank you. Have no questions anymore.
We can't hear anything.
Yeah, please turn the microphone on.
Oh, sorry. Okay, next, thank you. Next paper ID is 2073, improving piezoceramic artificial muscles for flying insect-sized mini robots. Oh, okay, the next is 2110, hydrodynamics of inhomogeneous jet. Well, maybe I will show.
Yes, yes, I'm here.
Okay,
Yes.
It's a very amazing title. Have your time.
Yep. Just a minute. Okay, is everything okay?
Okay.
With the demonstration? Yeah. And so, dear colleagues, for your attention is presented our report, Hydrodynamics of Inhomogeneous Jet Pulsating Fluidization. Yes. The rapid population growth is causing an increase in demand for agricultural products, the quality and quantity of which depend on agricultural land. However, over the last 40 years, more than 30% of the world's arable land has been lost due to the erosion and chemical pollution. Deterioration of the environment is forcing humanity to look for ways to reduce the negative impact on soils. In modern conditions, to increase yields, it is advisable to create complex granular organic mineral fertilizers containing mineral nutrients, deoxidizing additives, and humic substances that promote. Do you hear me? Yeah.
Yes, yes,
yes.
It's okay.
Sorry. Yeah. Granular organic mineral fertilizers must contain mineral nutrients, deoxidizing additives, and humic substances that promote simultaneous soil formation. To obtain a granular product with the desired properties, the most effective is the method of fluidization, which allows to combine in one device several technological stages with a heat factor of more than 50%. An important factor for the implementation of this method is hydrodynamics. The efficiency of the process kinetics depends on the hydrodynamic mode in a granulated chamber, which provides the required intensity of constant contact surface, recovery of gas, liquid, and soil solid phases by moving a significant mass of granular material. Therefore, the study of the hydrodynamic mode of fluidization, which provides active volumetric mixing of granular material with intensive circulation in fluidized bed without formation of stagnant zone in granulated chamber and on surface of gas distribution device is relevant because this allows to increase the intensity of diffusion controlled processes when supplying coolant with the temperature of coolant that significantly exceeds a melting point of thermolabile components such as nitrogen. The aim of experimental research is to determine the influence of the design of parameters of the gas distribution device on the intensity of movement of solid granular material along the working surface of the gas distribution device without the formation of stagnant zones. The main requirements for the granular products are the uniform distribution of components throughout the volume of granule, spherical shape, strengths of more than 10 newtons per granule, and the given dispersed composition. These requirements are achieved precisely by the layered structure and mechanism of granulation. The physical model of the process of obtaining granular humic mineral fertilizers with a layered structure mechanism can be presented as follows. The initial centers of granulation are heated to a temperature of bed that is determined by the conditions of mass transfer. Then they move into the irrigation zone, where for a minimum time, due to the adhesive sorption forces, on their surface is formed a thin film of liquid in simultaneous contact with the heated coolant. Then mixing with the dry granules, they are transferred into the relaxation zone with the filtration mode of fluidization, and filtration mode of dehydratation. Then they return to the beginning of the cycle, which is repeated many times until the specified size of granulated product is reached. The fluidization technique allows to ensure the combined performance of all of these stages in one device. For this purpose, is necessary to provide cyclic passage of granules through the corresponding technological zones in granulator as irrigation zone, relaxation, and intensive heat and mass transfer. According to the offered physical model, fluidization hydrodynamics in granulated chamber should provide, firstly, elimination of stagnant zones on the gas distribution device and in granulated chamber. Secondly, an active volumetric mixing of granular material with simultaneous movement through the technological zones in the granulated chamber. And thirdly, the intensification of heat and mass transfer processes during the granulation process. The physical model of inhomogeneous fluidization is that in the granulated chamber, the liquefying agent is injected in two levels, asymmetrically in the horizontal and vertical directions through the slits of gas distribution device. At points P and K, respectively, which conditionally divide the granulated chamber into three zones. Along the line of point Q is the merging of two jets, which leads to the formation of a combined torch with a breakdown height ZF. At its top, a gas bubble begins formation here. After reaching a critical size, the bubble begins to accelerate vertically movement and causes an inertial ejection of a significant mass of material into the space over the bed of material. Interacting with guiding insert, solid particles move to the surface of zone 1. The transferred material is rapidly returned to the voids in zones 2 and 3 to the initial equilibrium state, and the cycle is repeated many times. Thus is realized the inhomogeneous jet pulsating fluidization in auto-oscillating mode without the use of any pulsators mechanical. To implement the granulation process using a coolant with a temperature that significantly exceeds the melting point of thermolabile components, a particularly important factor is the elimination of stagnant zones on surface of gas distribution device. So the assessment of the hydrodynamic mode quality should be carried out in conditions of their absence. For this is proposed to use the function of loss quality for two components. The first component it takes into account the deviation of the porosity in zone D from a given 0.85. The second one takes into account the deviation of the length of the stagnant zone on the plate of gas distribution device. Is accepted to consider satisfactory quality at performance of condition 3. The ratio of the time of fulfillment of the condition 3 to the total cycle shows the index of dynamic quality of hydrodynamics. To determine the effect of the high height of the initial fixed bed of solids on the qualitative indicators of hydrodynamics was used a specially developed method for providing the experiment with developed computerized measuring systems based on photo video equipment and Arduino with low pressure sensors with a data capture frequency of 63 Hz. To determine the coefficients of hydraulic resistance was used the two-slit gas distribution device with two values of the cross-section coefficient 4% and 3.2%. As granular material was used granulated ammonium sulfate with human impurities with equivalent diameter 2.07 millimeters with density 1,450. The mass of the bed of solid granular materials loaded into the apparatus chamber varied from 11 to 17 kilograms, which determines the height of the bed of solids and the nominal hydrostatic pressure. Was obtained the comparison of hydraulic resistance coefficients of gas distribution device when the cross section coefficient changed from 3.2 to 4.9%. These results indicate that the reducing of the ratio of the cross-section coefficient by 34% leads to an adequate increase in hydraulic resistance value of gas distribution device by 32.4%. The fluidization curve was taken for the initial height of the bed of solids, 0.42 meters, as the gas distribution device coefficient cross-section coefficient 4%. Jet breakdown height ratio was 0.24. The obtained fluidization curve can be conditionally divided into 4 zones. In zone 1, when the fluidization number is less than 0.54, gas movement in the apparatus occurs in filtration mode, only in filtration. In zone 2, here, when fluidization number is more than 0.54 and less than 1, occurs a breakdown of gas jets that came out of 2 slits and merge into one with an upward motion, as a result of which a pulsation mode is released in apparatus. In zone 3, at these values of number of fluidization, the system operates in the bubbling mode of fluidization, which is characterized by an insufficient volumetric mixing indicates and the index and the formation of stagnant zone on gas distribution device surface. In zone 4, green zone, where number of fluidization is more than 1.71 and the speed of in the gas distribution device slits is more than 31.4 meters per second. The device implements a high quality self-oscillating jet pulsating mode of fluidization, which ensures the absence of stagnant zones on the working surfaces of gas distribution device. This is confirmed by obtained photo fixation of cycle of the state of the bed of solid granular material in the granulated chamber. After analyzing the obtained cyclogram, was determined the dynamic of change of porosity in zone D, and was established that during the entire pulsation cycle, quality loss function is less than 0.1. Increasing the initial height of fluidized bed by 23% to 0.52 meters, led to a decrease in the index of dynamic quality of hydrodynamics. In order to ensure index quality equal 1, when increasing the initial height of the bed of solids, there was installed a gas distribution device with a cross-section coefficient 3.2% in the apparatus, and was obtained the fluidization curve. Photo fixation of the state of the bed of solids for the self-oscillating jet pulsating mode of fluidization for a bed of solids with that parameters are given on this slide. From the graphs, it follows that the values of number of fluidization equal 1.71 and of gas velocity in the gas distribution device slits 38.73 meters per second. A high quality self-oscillating jet pulsating mode of fluidization is ensured during the entire cycle time. The porosity in the zone D is more than 0.85, and the quality loss function is less than 0.1, which eliminates the risk of formation of stagnant zones in the gas distribution on the surface of gas distribution device. Similarly, the fluidization curve was determined with the further increase in the height of the fixed bed of solids by 15% to 0.6 meters. Based on the obtained fluidization curve, the conditions for ensuring inhomogeneous fluidization were established, and at the same time was made the photo fixation of the hydraulic saturation in the granulated chamber. The dynamic of change in the porosity of the bed of solid granular material in the zone D corresponds to the conditions of the qualitative hydrodynamic mode more than 0.85, and the quality loss function is less than 0.1. Decrease in the cross-section coefficient of gas distribution device contributed to an increase in the height of the breakdown of the gas jet. At the same time, the diameter of the gas bubble increases and causes an increase in inertial removal of a bed of solids. And as a result of which stable kinetic of the granulation process is not ensured. Impulse removal of granular material into the space above the bed of solids causes inertial removal of granular material from the apparatus. To eliminate this disadvantage, it was proposed to install an elastic bumper in the separation zone of the granulator. From the obtained data, it follows that the experimentally using of elastic mesh bumper was confirmed, and it made possible to eliminate inertial removal of solids at the initial height of the bed of granulated material. Thus, it was experimentally confirmed that the implementation of jet pulsating and homogeneous fluidization in the self-oscillating mode without the formation of stagnant zones on the working surfaces of the gas distribution device is provided by increasing the initial height of the stationary bed of solids by 32% by reducing the live cross-section coefficient of gas distribution device. When the cross-section of gas distribution device decreases, the height of the breakdown height of the gas jet increases, but the diameter of the gas bubble increases. And this causes an inertial drift of granular material, which can be eliminated by using an elastic mesh bumper. However, the diameter of the formed gas bubble occupies more than a third of the device's width, which makes it impossible to ensure the necessary volumetric mixing of the bed of solids in the middle of the apparatus. To eliminate this disadvantage, it is necessary to provide a corresponding increase in the length of the device. That's all. Thank you for your attention.
Thank you, Sergey. It's totally not my fault, but I think it's very a huge work you did. So maybe participants have questions.
Yeah.
You are so full of presentation, so we haven't
Thank you
any
so
questions. Okay, thank you. And the next paper, 2138, approach to improving the accuracy of machine learning models in requirements, elicitation, technique selection. You can stop sharing the screen.
Sorry, yeah.
Okay. The next paper, presenter, are you here? Okay, I will share. Oh, sorry. It's not. Okay, and the last in this schedule session, analysis of threat models.
Yeah,
for
I'm here.
Unnamed. Okay. Hannah?
Yeah. Good
screen?
afternoon. Just a second. I will share my screen. Does everybody see my screen?
Yes.
So good afternoon for everyone. Today I want to show you our work, analysis of threat models for unmanned aerial vehicles from different spheres of life. And presenter of this work will be me, Hanna Martinyuk. I'm from Mariupol State University, that for today is state on the Kyiv. So, unmanned aerial vehicles are a class of robotic vehicles that can carry payloads and execute flying missions guided either by remote control stations or in an autonomous way. Unmanned aerial vehicles are very mobile, which enables them to function even in remote areas where there is no physical or technological infrastructure. Purposes. However, with their increasing popularity, technological advancements and awareness among the people in industry and research, their applications are no longer limited to military applications. As highlighted in this figure, you can see that some of the different applications inspections, delivering goods and medical supplies, video capturing and filming, and surveying. Unmanned aerial vehicles are becoming more and more popular in the world. The scope of their application is expanding, from military measures to the operation of rescues, doctors, firefighters, etc. In modern conditions, the use of UAVs and robotics has become the usual norm. With their help, the tasks of ensuring military security, as well as issues in research security and other areas, are solved. In the fight against terrorism, drones and other types of robotics are becoming an increasingly effective and regularly used tools. However, it should be noted that today there are problems with the protection of such UAVs from unauthorized hacking and use. Thus, a number of publications describe the main problem of UAV cybersecurity. Based on this analysis, the authors decided to compile a threats model depending on the possible methods of attacking aircraft. At the same time, terrorist organizations are trying to keep up with progress and are actively using unmanned vehicles in their destructive activities. Therefore, consideration of issues on the use of UAVs and countering them must be carried out in parallel. Only the general application of UAVs is considered in the literature for compile a threat model. At the same time, it is impossible to equally assess the threats and risks that affect the confidentiality of these drones in the civil and military spheres. So, for example, the loss of data confidentiality during aerial reconnaissance of the state of crops will not cause such damage as the loss of data confidentiality during aerial reconnaissance of enemy sites in war. In this regard, the work will consider a model of UAV security threats depending on their areas of application. An unmanned aerial vehicle is a device that is controlled remotely without the direct participation of the pilot. The UAV consists of the following components: an air platform with a special landing system, a power plant, a power supply system for all components, and avionics equipment. The general classification of UAVs is given in the table of this slide. So UAVs can be classified based on various parameters such as flight mechanism, weight, flight, altitude, and wind type. Based on the flying mechanism, UAVs can be categorized in such categories. So it can be something like multi-rotor or rotary wing UAVs, it can be fixed wing, it can be hybrid fixed or rotary. Also, it can be micro UAVs, very small, medium, large UAVs, or depending on the altitude at which the UAV are designed to operate, they can be classified as For creating and analyzing threat models, authors decide to use only usage methods like classification feature. The security
Anna, sorry, we can't hear you. Anna, you can, a technical problem? Okay, maybe we will wait 1 minute to Anna. She may be reconnected to us.
Nice and big now. I'm sorry I didn't hear around the number of 2099.
Okay, super.
Okay.
You will be next, maybe.
Okay.
Okay.
Hello, everyone. My name is Yihong Liu, come from Wuhan University of Technology. The title of my article is Development and Application of Shape-Lock System Simulation Models Library. Next, I will introduce my article from 6 parts. First, from 5 parts. First, introduction. Second, model library development ideas. Third, systematic construction of the model library and description of the model structure. Fourth, application validation of the model library. Fifth, conclusion. Part 1, introduction. System simulation technology is one of the most effective tools to analyze complex engineering systems and attracting much attention of many researchers in recent decades. Many works have used system simulation technology to solve the real problems of discrete event dynamic system in transportation, mathematics, engineering application. As a typical discrete event dynamic system, the log system has complex characteristics such as nonlinearity and uncertainty. So many scholars emphasize on analyzing the passing ability and the reliability of the log system through simulation, so as to conduct more in-depth research on the shape log system. However, when building the simulation model of the log system, the system boundary, system construction, and the logical flow of the log should be analyzed first, and then the model is built, which requires not only familiarity with the logistics activity and operational operations of the log, but also proficiency in using different simulation software. Therefore, the modeling period is often long. In view of this paper deeply analyzes the complex relationship of the log system, expounds the development ideas of the system simulation model library, and develops a set of object-oriented log system simulation model library, which users can use to quickly build the log model through simple steps, such as dragging in the model, establishing logical connection, and entering basic data. Part 2, model library development ideas. In this part, I built 2 models. One is object model of the shape log system, and the other is dynamic model of the shape log system. The object model of the shape log system is mainly based on the object modeling. The main objects of the extracted log system are anchorage, scheduling center, a port channel, waiting area, log door, log chamber, and filling and emptying system. The specific descriptions are as follows. Anchorage, for ships to wait at anchor, with 2 states of idle and occupied. Scheduling center, scheduling the log chamber according to the scheduling plan, generating the log chamber scheduling chart and issuing scheduling instructions to the vessels at berth. Third, a port channel has dimensions and can be occupied or vacant. Fourth, waiting area. When the water level adjustment inside the gate is not completed, vessels can wait in the waiting area. Fifth, lock door, open or close. Sixth, lock chamber, with dimensions for ships to berths waiting for water level adjustment, vacant or occupied. Seventh, filling and emptying system. Regulate the water level elevation inside the gate by watering and sluicing water. The object model of the ship lock system is shown in Figure 1. As a typical complex discrete event dynamic system, the dynamic model of the ship lock system is mainly used to describe the instantaneous and behavioral control characteristics of the system. The main events in the lock system are ship's declaration, ships entering into anchorage, dispatch center generating the lock chamber scheduling chart, ship entering into a port channel, filling and emptying system regulating the water level, lock door opening, lock door closing, ships entering into the lock chamber, and ship leaving the lock. The dynamic model of the ship lock system based on the above events is shown in Figure 2. Part 3. Systematic construction of the model library and description of the model structure. The object model and the dynamic model based on the object-oriented modeling methods are the important basis for the division of the log system simulation model library. And the main systems of the log system simulation model library are ship plan generation and scheduling model, a port channel model, log chamber model, data status model, and public variable model. First, ship plan generation and scheduling model. Components, vessel, dispatch plan, vessel security check area, anchorage, input and output interface. Function, generate ships, complete the declaration and the security check activities respectively, and enter the berth system for berthing. After the scheduling plan is completed according to the registered ship attributes, the dispatching system will issue a lock door or crossing command to the ship to realize the scheduling function. Second, a port channel model. Components, a port channel, waiting area, input and output interfaces. Function, the navigation route of the ship from the anchorage to the lock door is specified, and the ship can queue up at the waiting area near the lock door to prepare for entering the lock door. Third, lock chamber model. Components, locks, chambers, filling and emptying system, input and output interfaces. Function, the water level inside the lock chamber is adjusted by the filling and emptying system so that the water level in the two adjacent levels of the lock chamber is equal, and the ship completes its passage. At the same time, the ship can moor and wait inside the lock chamber during the water level judgment. Fourth, data statistics model. Components, histograms, pie chart, variables, and other tools to use to count each indicator. Function. In the simulation process, the data such as the passing capacity of the log system, ship waiting time, ship crossing time, and the occupancy rate of the log chamber area are counted. And quantitative data are obtained to analyze the problems studied and find ways to solve them. Fifth, public variables model. Components, public variables, and attribute variables for each model entity element. Function. As an auxiliary model, it mainly consists of common variables and attribute variables of each model. Part 4, application and validation of the model library. The three gorgeous logs are double-line continuous 5-stage logs, and the basic components of each line of logs are anchorage, a port channel, log chamber, log door, and filling and emptying system. The layout of the three gorgeous logs system model is built based on the Figure 3. Each line of logs consists of anchorage, a port channel, and 5 levels of log chambers. The selected basic models and the required quantities are shown in this table. On witness simulation platform, tracking models, then establish the logical relationship between models, import data according to the data parameters of three-gorgeous shape log system, and complete the simulation model of north line shape log. The screenshot of the established three-gorgeous log simulation model in witness is shown in Figure 4. According to navigation data statistics released by the Yangtze River Three Gorges Navigation Administration, as an example, the design model simulation time is 739 hours. Through the simulation experiment, we can get the simulation data statistics of three gorges logs. From this table, we can analyze. Firstly, in terms of the number of shapes, the difference between the model simulation data and the real statistics is the percent of 0.7. Secondly, the simulation data of the three gorges log model is almost the same as the actual reality statistics. Thirdly, it can be seen from the table that the passing capacity obtained by the model simulation increased by the percent of 22.72 compared with actual statistics. But this does not explain the incorrectness of the model because the freight volume of inland water transportation is unbalanced, or there are still more small shapes. The actual statistical cargo volume will be less than the model simulation data. In the end, conclusion. The log system simulation model library based on object-oriented development can quickly build logged models, reduce the construction time of the model required for research, and more systematically and intuitively explore the logistics technology problems in the planning shape log system or existing shape log systems. Review the mechanism of arouse complex factors on the passing capacity, ability, and the reliability of log system. The model library also has excellent scalability and portability, which can facilitate users to modify the parameters and the model structure according to special needs. The simulation application case of three gorges logs shows that this model library has important practical value and will greatly improve the research efficiency of the logs. That's all. Thank you.
Thank you. Any questions?
I have a question for you.
Okay.
I can see from you share that you built a modern library, which is a really good idea. But there should be building a modern library. That is an assumption. You should have some assumptions here. So describe them in detail. Thank you.
Okay. Thanks for questions. Before developing the library of simulation models for the shape log system, I have made about 3 assumptions for different aspects. Firstly, the boundary of the log system simulation model is the anchorage of the log where the shape enters and the end of the channel of the shape leaves the log chamber. Secondly, it is assumed that each passing shape is an independent individual and the shape can run as soon as it enters the simulation without breaking anchor in the middle. Third, vessels pass through the log door according to the principles of priority arrangement for key shapes and the first come first served for general shapes. Fourth, the shape is a temporary entity of the simulation system, and it is found that the time interval of shape arrival obeys the negative exponential distribution, and the shape type, of course, in the log door is classified according to the size and the quantity, obeys a certain probability distribution. Fifth, when the ship is moored in the log chamber, there are safety distances between the ships in the longitudinal and transverse directions, which are reflected in the mooring length and the berthing wise of the log chamber. That is, the two are calculated by subtracting the safety distance from the original size of the log chamber. That's all.
Okay, thank you. Next question. Okay, we have any questions. Thank you for your presentation. We finished our first part of section. We have
2192.
2192 the next, but we have for
the next 2191.
No, next paper is 20 after. I think we haven't. We will not have a break. Yes. You won't present your presentation now. So next is 2191 presentation. Are you
Thank
here?
you.
Okay.
Yes, I
Have you
will
time?
show my screen.
Okay.
Can you see my screen?
Yes, yes, we see.
Good afternoon, dear participants of the conference. I am Olena Dimchuk from National University of Water and Environmental Engineering from Rivne. And my co-authors are Volodymyr Kovalchuk, Alexander Wojtowicz, and Pavlo Kovalchuk from the Institute of Water Problems and Land Reclamation of the National Academy of Agrarian Sciences of Ukraine. I'd like to present you our report on the topic identification of soil water potential sensors readings in an irrigation control system using Internet of Things, automatic tensiometer, and watermark 200 SS. In the context of climate change, the rational use of irrigation water is the basis for sustainable development of agriculture. It is impossible without the use of the information system for operation irrigation control, which is based on field networks of various sensors, that is, on the use of the Internet of Things, IoT. Many researchers use watermark 200 SS sensors to control irrigation in their field moisture sensor networks. Meter Incorporated developed and patented a whole series of such sensors. However, the given formula for the relationship between soil water potential and watermark 200 SS resistance and soil temperature is recommended for soils of light mechanical composition. The problem is to develop a method for conducting experimental studies and identifying dependencies based on experimental data for an arbitrary type of soil. The purpose of the study is to develop a method for identifying the relationship between soil water potential and watermark 200 SS regions and soil temperature values based on data from laboratory studies of soil samples for various soil types. The identified dependencies are used to calculate the soil water potential and assign watering in irrigation control system using the IoT sensor system. The identification method based on experimental studies and mathematical modeling on the relationship between soil water potential and electrical resistance measured by watermark 200 SS at different temperatures is proposed. Experimental, do you see my figure first, figure 1?
Yes, just number one.
Okay, thank you. Experimental equipment, figure 1, which is able to maintain the soil.
Young lady, first slide, not the picture one, not the third slide.
Mm-hmm. And now?
And now, wonderful picture with something beautiful mechanics, and I believe moisture sensors and some another sensors, pieces of ice, and wireless models in the box. Yeah, wonderful picture.
Figure 1. Okay.
BMP2.
Experimental equipment which is able to maintain the soil temperature in the soil monoliths of an undisturbed structure within the specified limits using the control 5, Arduino Nano version 3 IT Mega with a relay that controls the aquarium heater was designed and manufactured. The transfer of commands by the user to the server and from the server to the relay through the Arduino controller is carried out remotely using the GPRS module. The water temperature and the temperature inside the soil monoliths are measured by digital sensor 3 Dallas DC 18B20 located inside a stainless flask using thermally conductive paste. The data of vacuum pressure and electrical resistance of the watermark are received and collected using the Arduino Nano version 3 80 Mega control 6 and transmitted to the server using Wi-Fi. Watermark 200SS sensors too were calibrated using automatic tensiometers, which were developed at the Institute of Water Problems and Land Reclamation of the National Academy of Agrarian Sciences of Ukraine, based on a BMP 218 digital vacuum gauge 1, and also the BMP 280 has a significant drawback. It is afraid of water getting on the sensitive element. Its advantage is high accuracy in measuring vacuum pressure. It can be good that both sensors measure the water potential of soil moisture. The automatic tensiometer directly measures the vacuum pressure equal to the modulus of the soil water potential, and the watermark 200SS is calibrated in potential units. At present, the relationship between the parameters P of R and T of watermark 200SS sensors are determined by the formula 1. To identify the coefficients of nonlinear equation 1, we write it in the form 2. Or formula 3. Dependence 3, in contrast to equality 1, is linear. Therefore, the coefficients of that model ABCD can be identified by the least squares method. C, R, and D are determined according to the data of the laboratory experiment. Then for the initial value S, the input values S multiply R, S multiply T, and R of linear dependence 3 are calculated. The coefficients A, B, C, D of the linear dependence 3 calculated from the experimental data by the least square method are for a type of soil which is used to bind the readings of both sensors when monoliths of the undisturbed structure of heavy low Chernozem soil were selected at the experimental production site of the State Enterprise Experimental Farm in Andriivsky in Odessa region from the arable from 10 to 25 centimeters and under arable from 30 to 45 centimeters horizons. In the process of laboratory research, there was a problem with the cracking of the monolith with the soil of the under-arable horizon, and as a result, the constant loss of vacuum by the soil medium and the tensiometer. The physical properties of both soils are similar. Therefore, despite some loss of information content of the experiment, the results are given according to the studies of one monolith. The monoliths were tested in the laboratory at two temperature thresholds of about 20.6 degrees Celsius and about 24.65 degrees Celsius inside each soil monolith. The monoliths were saturated close to full capacity and then dried naturally. The vacuum pressure with a tensiometer based on the BMP 280 sensor element pressure resolution is 0.16 pascals. The gypsum block resistance in the watermark treated SS sensors and the temperature of the water around the soil monoliths were automatically recorded. A comparison of the dynamics of vacuum pressure according to the readings of the automatic tensiometer and the calculated values of the readings from watermark according to the Formula 1 with the coefficients for light soils at different values of the gypsum blocks, electrical resistance of the sensor was carried out. Figure 2. Section 2 has a temperature threshold of about 20.6 degrees Celsius, and section 3 has a temperature threshold of about 24.65 degrees Celsius. A visual analysis of dependencies in Figure 2 shows the systematic deviation between the readings of the automatic tensiometer and the calculated vacuum values, soil water potential. According to the electrical resistance, are data from watermark on all 4 sections of the curves. The relative error in sections 2 and 3 of the systematic deviations to calibration was calculated using the Formula 4. According to the experiment plan, after the initial unstable period and soil monolith maximum saturation reaching from the 24th of January 2022, its natural drying began at an average temperature of 20.6 degrees Celsius, which was detected by the sensors Figure 2 curve section. The maximum vacuum value was reached on the 4th of February 2022. Another drying cycle, section 3, after reaching the maximum saturation of the monolith with water lasted from the 7th of February 2022 to the 21st of February 22. The sensors recorded the average temperature for the cycle of 24.65 degrees Celsius. Based on the obtained data, 2 curves of the dependence are of P were plotted at a certain constant value of the soil temperature, figure 3. As can be seen from figure 3, in the area close to the full moisture capacity, there is an uncertainty in the electrical resistance of watermark 200 SS equal to a certain constant value. As a result of mathematical, just a moment. As a result of mathematical processing of the experimental data by the least squares method, table 1, the coefficient of formula 1 for soils of heavy mechanical composition were obtained. The root mean square error between the calculated values and the experimental values is 10.77. The formula with the obtained coefficient taken into account the satisfactory accuracy of the results should be used when assigning irrigation for heavy soils. The dependence of vacuum pressure soil water potential was calculated for various values of soil temperature with obtained coefficients. Dependence graphs are shown in figure 4. The use of an experimental equipment for several temperature thresholds with the ability to constantly maintain it in a comparison with the calibration examples described above makes it possible to obtain experimental data at various temperature thresholds. To highlight in detail the effect of temperature on the watermark 200 SS resistance, and on soil water potential for any soil type. In particular, there is done for soils of heavy mechanical composition. Results of watermark 200 SS sensor calibration can be performed both for a single field soil and other soil types. They are extrapolated for other temperature values and for any soils of heavy mechanical composition. This makes it possible to effectively use the watermark 200 SS in irrigation control systems for watering assigning. As the results, as the analysis shows, in irrigation control systems, many farmers use watermark 200 SS sensors for field networks for measuring soil moisture by indirect method. However, in order to watering assigning through measurements by these sensors, it is necessary to identify the readings of the soil water potential. There is such dependence only for light mechanical composition soils. Therefore, in our study, the problem of developing a method for finding a functional dependence between the soil water potential, the watermark 200 SS gypsum block resistance, and the soil temperature P of R and T was formulated and solved. The method makes it possible to obtain experimental data on the relationship between electrical resistance and soil water potential for an arbitrary soil sample on experimental equipment. On the basis of experimental data, a method of identifying the parameters of linear dependence is presented, which ensures the identification of a nonlinear model of the relationship P of R and T. The experimental approach and the identification of nonlinear models provided a constructive implementation of the method for identifying the nonlinear relationship between water potential, resistance, and soil temperature P of R and T for soils of heavy mechanical composition. In the future, it is possible to implement the method for creating a knowledge base of models coefficients and in automated irrigation control system during watering. Thank you for your attention.
Thank you. Any questions? Okay. We haven't any questions. Thank you for your presentation. The next presentation is 2138. Dennis Gobo. Yes. We have a modification of our conference program yesterday. So I think some of participants have not a new version of this program. So we will finish the first part of our section. It's paper 2138 and 2075. Next. Okay.
Yeah, thank you. Do you see my screen? I hope that yes.
Yes, we see.
Okay, great. So, dear conference participant, let me present our research with the title Approaches to Improving the Accuracy of Machine Learning Models in Requirement Elicitation Technique Selection. So, first of all, I want to say, this study was conducted by Olga Solovey, associate professor from. Oh my God.
Там start presentation, там є таке, і тоді його розшарювати, а не просто, ну, то не важно, дякую вам, все, завершили, вроді, як так, нормально.
Я перепрошую, I'm sorry that somebody is talking in parallel with myself. Can I continue my speech?
Yes, you can.
Okay. Yeah, so this study was conducted by Olga Solovey, associated professor from Kyiv National University of Construction and Architecture, and by me, Denis Gobov, associate professor from National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. So, first of all, I want to say several words regarding relevance of this topic. The choice of techniques for effectively identifying or elicitation requirements in developing IT solution is essential in planning business analysis work. An understanding of the variety of techniques available and their advantages and disadvantages assist the business analyst or requirement engineer in adapting a particular project context. The business analyst must create a combination of techniques to guarantee the success of software requirement identification activities, as it's impossible to fulfill all project stakeholder needs using just one technique. One of common approach to solving this problem is machine learning models. Their training sample usually are formed based on practitioner experience or recommendations, can be considered as an instrument for business analysts to choose the proper techniques. However, when such model is built, the data scientist must pay attention to the fact that the machine learning algorithm must deal with imbalanced data set. For example, as a result of survey, which we conducted in 2020 in Ukraine, such technique as an interview was chosen by 286 respondents from the total 324 who participated in this survey. And another example, elicitation technique document analysis was selected by 280 respondents from the same total amount. As a result, we received the following characteristic of training data set. Let me switch to the next slide. Yeah. So you can see that imbalance ratio, this column, is pretty high for such popular techniques as an interview, document analysis, and is less for interface analysis and process analysis. But in any case, these values are pretty high. So, problem statement. Such algorithms like a binary decision tree learner or jungle tree creates a tree that is biased to the majority class, then a data set is imbalanced. The reason causes are the following: by recursively partition the data set so that the observation with similar target values are grouped together. It qualifies the candidate split of the node using the parameters that minimize the impurity. You can see the formula for impurity calculation on this slide. BRG from QMT is calculated as a sum of entropy of the left and the right nodes after the split. When the data set is imbalanced, there is a significant probability that most class samples are put in the same nodes, which makes entropy close to zero. As a result, the Crates tree is biased towards the majority class. In the picture below, you can see very low impurities visible for imbalanced data set, which is evident that the node included the majority from the same class. Related works. Yeah. As I said before, data set was received as the result of conducted survey, and machine learning model was built based on this data set to recommend the usage of elicitation technique depending on the combination of project factors. Yeah, it can be project size, it can be methodology, it can be experience of involved specialists, so on. The model was constructed through the following steps. First of all, the step regarding data preparation and acquisition. Yeah. Irrelevant records were removed. Respondent answers are transformed into mutually exclusive classes. Usage of particular elicitation technique is set to 1 and otherwise set to 0. The next step is data preprocessing. A data set was split randomly into 2 parts for training and for testing. So we used common coefficient 0.75. The next step, modeling. The decision jungle tree algorithms was empirically selected as most efficient from the accuracy and area under curve AUC metrics perspective. And the last step is model validation. The models was validated using such metrics as accuracy, AUC, precision, and recall. Unfortunately, this fact that original data set was imbalanced had not been considered. And this problem negatively impacts the model performance. Yeah, the high value of accuracy, you can see that for such technique as an interview and document analysis, accuracy were higher than 0.5, and relatively low value, approximately 0.7 of the area under ROC curve, yeah, AUC. AUC is an accurate indicator of the model's prediction ability when data set is imbalanced, because it shows the ability of the classifier to rank the positive instance relative to the negative ones. Yeah? And it's especially critical for such popular technique as an interview and document analysis. So the purpose and objectives of our study. We want to enhance the built machine learning models by adding a data preprocessing step, which is to balance the data set before training and machine learning algorithm. And the second one, we want to measure a new model based on the same metrics to obtain the prediction comparable result. Regarding methods, yeah, data preprocessing, we generated synthetic samples that diminishes the class imbalance problem with methods mode. So it's pretty known method for correct imbalanced data. The applied technique got a new sample. You can see the formula for calculation as a linear combination of 2 samples from the minority class, XR and X, with the following limitation, where XR is randomly chosen among the 5 minority class nearest neighbors of X. On the model validation stage, we use independent from learning algorithm filter methods to estimate features importance score. That action guarantees that estimated features importance is not affected by a learning algorithm bias. So the data preprocessing result, the result of using smooth algorithms. Splits impurity increased after the data set was balanced by applying smooth, which indicates that more samples from different target classes are included in the node. Both classes are presented before the decision in favor of the majority or minority class is made, and the created tree is not biased. The gap between mean entropies is approximately 10% for data sets with imbalance ratios of more than 5, and it's 5% and 4% for data sets with imbalance ratios of 2.5 and 1.9 correspondingly. The graphs below on this slide displays the direct dependency between the decision tree bias and the dataset imbalance ratio. The next step is modeling result. Orange lines on ROC graphs to predict techniques such as an interview and document analysis almost passed through the point with coordinates 0, 1, which is a sign of the ideal classification. It's the first two graphs. So the classification which result are false positive, FRP in 0, and true positive rate, TPR is 1. So we receive really better result than in case of imbalanced data set. And you can see that we received improvement for each techniques, for interviews, document analysis, interface analysis, and process analysis from ROC point of view. Model validation, the result of this step. This summary table with validation results indicates that model's prediction improved level of AUC is 35%, 33% for interviews, 33% for document analysis and interface analysis, and slightly low 16% for process analysis. Accuracy equation is the ratio of the sum of correct predictions to the total number of observations when data set is imbalanced. Then the sum almost corresponds to the number of observations which are included in the majority class. The accuracy matrix indicates fewer improvements for interview and document analysis. You see that 0 and 1%. Compared to the interface analysis and process analysis, where we have 6 and 5% respectively, because in the previous work, when we use imbalanced data set and jungle tree classification, accuracy matrix was collected on imbalanced data, and we had prediction bias to the majority class. Which important identification. Free filter methods were tested with the balanced data set to identify which methods better explains the dependencies between independent feature and target class. The first one is chi-square stats, measures dependency between non-negative features and class, so that irrelevant for classification feature is set a low score. AUC values are 0.98, 0.96, 0.88, and the same for process analysis techniques when the features are selected by chi-squared stats before modeling. The second one, analysis on variance. Oh my God, sorry. The next one is mutual information. Measures the amount of shared information between independent feature and target class. We can detect non-linear dependencies, and AUC values are 0.98, 0.97, 0.9, and 0.88 when features are selected by ANOVA F-test before modeling. And the last, and in this case, the least efficient, was analysis of variance ANOVA F-test measures the ratio of explained variance to unexplained variance. The higher values mean more features importance to a target class. AUC values are 0.97, 0.97, 0.88, and 0.87. Yeah, when features are selected by ANOVA F-test before modeling. So we can say that mutual information provided the best result from AUC value perspective. Yeah, we noticed that the slight dominant of ROC curve when features are selected by the mutual information method. So we chose this method for feature scoring. We propose to use feature importance score in the future while developing a recommended system of both types, collaborating filter and content-based filtering. The result obtained in the current work indicates that depending on indicators such as a project size, BA experience, way of works, the system may recommend an elicitation technique. Yeah, and you can see this feature list and appropriate score defined for each elicitation technique separately. Yeah, for interviews, for document analysis, for interface analysis, and for prose analysis. Yeah, so it's easy to collect that project size, BA experience, and WOW are in the high part with the highest value of score for all 4 techniques. So, conclusion. Yeah. Several enhancements are proposed and successfully verified by a testing procedure to balance the data set, but by applying smooth methods before modeling. As a result, improvements in the accuracy indicator was obtained in the range from 0 to 6%. Previously, I provided explanation why for some cases, for some techniques as an interview and document analysis, the accuracy was not improved so big, and the AUC indicator was improved from 16 to 35% depending on techniques. To calculate the features importance score independently from the machine learning classifier, and the approach guarantees that the feature score doesn't depend on learning algorithm bias. Yeah, and I said before, we defined that the best result were received via using mutual information. So that's it from my side. Thanks a lot for your attention. I am ready to answer your question.
Thank you. Any questions? Okay. Thank you for your presentation. And next speaker is paper ID 2075.
Yeah, I'm here.
Okay. Can you share a current screen?
Okay.
And you have every speaker have 10 minutes for presentation and 5 minutes for answer the questions, and you can start. Okay.
Okay. Can you hear me?
Yes, yes. We see the screen and hear you.
Okay, I will report from the following 5 aspects. The first one is introduction. Flow picking and picking is the most common, basic and necessary operation in the harvest season. Using advanced automation technology and equipment can greatly improve the increase of flow harvest. The local decided to complete these operations. Highlight is unique advantage. As an advantage design method, TIA aims to define and overcome some key problems that may affect product development through potential innovation solutions. This paper analyzes the problem of low efficiency, low safety, high label intensity, and the integrity of the flow in the sorting process of passion fruit put forward the conflict the solution matrix of the platform design of passion fruit sorting robot based on TI theory. And estimates the problem's solution of structure decides through the problem's invention principle. Second, the main contents of TI theory include 40 invention principles, 39 engineering technology characteristics, fundamentals, and the conflict resolution method is done by using 39 general parameters and 40 invention principles, as well as the material fit analysis release and the invention problem solving ARIZ. The method for TI to solve the invention problem is shown in Fig 1, which can be carried out in 4 steps in the process of using TI theory to solve the invention problem. The invention problem to be solved should be classified and then the problem to be solved by the object to design should be converted into a general problem expression by means of meta-fit analysis and other methods. That is the general model of the problem should be established, and then the general solution of the general problem should be defined by using 40 invention principle and tools provided by TI theory. Thus, in order to mainly resolve the problem and solve robot platform more creative and adaptive, this paper use TI theory to guide the design, but the key is to do a good job in the breadth and both processing of specific problem analysis. The process is as follows. First, analyze the special engineering problem to be solved in the RNDM design. Establish a general problem model according to TI. Analyze the improved and deteriorate engineering technology, technical parameter. Determine the composting invention principle in the technology conflict matrix, and obtain the general solution, and finally determine the best special solution by combining engineering knowledge and experiment. And the meta-fit analysis of TI series is used to establish the decryption model of the passion flow cramping and sorting robot platform to determine the technology conflict. as well as in Fig 2. 39 general technical parameters are used to analyze and describe the above technical conflicts, and parameters for improvement and degradation are shown in Table 3. Compared with Table 3, the corresponding invention principle series number is TI is the 40 invention principle can be contained, and the invitation principle theory number to solve the problem are shown in the Table 4. Number 4, according to the guidance of about invention principle, the overall design of the team-free through cramping and sorting robot platform can contain the overall structure shown in the Fig 3, including the CDB pressure recognition system and the main body of the sorting manipulator, the end effects of the cramping manipulator and translation model, and automatic control system, and the collection model. And use the principle of parameter change to change the flexibility of the object. The joint M content brand of the brain painter figure of the end attachments are made of solid rubber, and the spring is set as a path to increase flexibility and solve the problem of fluid damage during crashing, and structure of the end actor is shown in Fig 4. Use the feedback principle to adapt to different needs by adjusting the size and sensitivity of the feedback signal. And we can show in the Figure 5. And the conclusion is that the specific engineering problem to be solved in the development and design of the team through cramping and sorting global platform, and establish a general problem model according to DI's analysis for improve and engineering technology parameter, and for better relate the engineering technical elements in the design process according to the conflict messaging, and the invention principle suitable for the design is obtained. According to the design of without the structure of the pass-through cramping and sorting global platform is complete, which can meet the set functional requirements and meet the design requirement. That's my report. Thank you.
Okay, thank you. Questions? Oh, we have any questions?
Professor.
Hello, yes.
Hello, Professor Huang. Your research is about the application of TRIZ innovable design method in measured product design. Obviously, it is innovable and commensable. Here, I have one small misgivings. Is the TRIZ method the only solution? Thank you.
Okay, thank you for your question. The TRIZ approach is not the one solution. In the process of the mechanical prototype, a total of 39 engineering parameters and 40 invention principles are involved in TRIZ method to solve technology contradiction. And the 40 invention principles include segmentation and abstraction, logo mix, and so on. Thank you. Thanks.
I have another question. With you discuss. How do you choose the best solution, if not the only one? Thank you.
In the process of determining the past invention principle, it is necessary to first analyze the improved technical parameters and the technology parameters, and then stack the most suitable invention principle according to the conference message. Thank you.
My last question is TRIZ applicable to other areas as well? Thank you.
TRIZ is not only suitable for mechanical structure design, but also for automobiles, education, management, and other fields. Thank you. No.
Okay, thank you. Any questions? Okay, thank you, dear professor. The next presentation in paper ID 2192. Machine algorithm, learning algorithm comparison for software testing errors, classification, automation. Okay.
Okay. Okay, and our team have some presentation. For example, I write to chat 2192, 2224, 22, I believe, 26. So can we replace some of them? Let first will be 22, 24. It will be normal. Olechenko also located here. So let's begin. Let's start my presentation. It's ready, and I turning on the screen demonstration. One moment. Quality of the picture normal. Text readable. Text also readable, I believe. Good afternoon.
Okay.
Good afternoon. I am Andrei Moshinsky, full name, and our team from 3 universities, you can see from Kyiv City, from Polytech, from Technology University, from Food University. We all together work in different organizations and sometimes replace organization. And our wonderful team want to say some words about sub-gigahertz wireless sensor network for smart clothes. And I believe it will be interesting for everybody. An introduction, some problem. to research in the objective research in sub-gigahertz wireless sensor network development allows increased coverage area for manufacturers of military troop sheets with zonal alignment of temperature, relative humidity, and other parameters. So our main problem is area of coverage increase. So let's continue. Recent research and related work. You can see that a lot of publication was last years, maybe not only last years, maybe last 20 years. Well-known manufacturers, something like Adidas, something like Numerex, have some proprietary and another radio band, industrial science medical band radio systems. So this research vector is very important. Some words about smart clothes. Smart clothes researches development materials, integrated radio modules, integrated sensors, various materials for body comfort, and another tasks on this for these reasons. So materials and research method. We wanted to make a new smart clothes. Really sorry, but now it's war in Ukraine for military tasks for our troops, and it was made by a small battery. Atmel MCU, it's no difference between Atmel 88 to 328, something 8 kilobyte memory, not more. The next, I see another latest is also use Dallas 18B20 sensors of temperature. The next, humidity sensors, we use it another type. We use it Amsong 2301 and 2302, and we opened the case of these sensors and make the thickness of the sensors very small. Next, radio modules. You can see the Numerex, Adidas, and another manufacturers use industrial science medical band 2400 megacycles. Baseband usually something like Bluetooth, Wi-Fi. It's have not very long range for data transfer. And we use it another radio model, something like Scilabs 4432, 4463. It's usually frequency shift gain, amplitude shift gain, transceivers with output power 100 milliwatt less, usually 10 milliwatt less, and it can be used as you see in industrial science medical band in Ukraine on 433 megacycles, in Europe 867 megacycles, no, close to this band. For North America 915 megacycles, so industrial science medical standard. On the server side, we use the same radio model connected to proprietary interface or another, something like UART or VSPI interface by another host microcontroller. It's no difference. We use it UART with our system. Future data processing goes by processing the data stream on serial interface on our server side. Schematic of our model. On the left side, on the top of left side, you can see some temperature sensors. You can see that it's one wire bus, so a lot of sensors can be located on the same bus. 64 bits, I believe, it's address field of this bus, so it's no problem. Next, GPO for temperature, humidity, how much sensors you need, so much GPO you need. The next I2C bus, now don't use it. Sometimes we can use Amsongs on I2C, but really no difference, and in this usage it's not very important. The next interface on the top and right side. UART interface, serial interface, connected radio module on Scilabs 4463 and STM8 Sierra host microcontroller. Maybe you know these models like HC12. HC12, it's radio with WART interface. Very, very useful, wonderful models. The next, a power supply unit. Without protection, without battery management system, we have no chances if we want to work with lithium-ion battery. You can see on this slide, lithium-ion battery have a capacity less than on previous slide because some modification of this device was made. The next picture, you can see the location of our sensor. On the front side, on the back side of our T-sheet, you can see that sensor's location is standard for military application. It's really standard. But you can see that our sensor unit, microcontroller module, I write on this picture, located on the upper back side of our sheet. The next, pictures and another usage of another controller for this reason. You can see the power supply unit, small lithium-ion battery, then the connected, usually USB WART module for power supply for this reason, then a microcontroller and another board. You can see by number 7, 8, 9 a board with microcontroller, then located accelerometer ADXL 345 for measuring of acceleration of moving objects. Sometimes we need to know something about hard work of our soldiers. So, and also small lithium-ion battery, and you can see wires connected to the temperature, humidity, and other sensors on the dress on the sheets of our experimenter soldiers. Okay, the next picture. You can see another block diagram for moving object monitoring system. We can use any frequency band for public usage, for example, Wi-Fi, and the wonderful model on the previous slide. You can see ESP8266. Maybe it can be also ESP32, ESP13C something, it's no difference. So sensors, host controller, power supply, also battery management system, an antenna, and Wi-Fi connection to usually router and to the internet. Classical Internet of Things structure. The next picture is our proposition. Pay your attention, please. Something like previous, but oh, I'm sorry. See the interesting differences. I write the name of controller to it be user-friendly, something like Arduino, but no difference. I like Arduino without bootloaders, but it's my choice. Also sensors, power supply unit, host microcontroller, and then radio module, not Wi-Fi, not Bluetooth. Radio module with frequency shift key and with coverage on very high or ultra high frequency band. It's our module size. The next, our server size. Another host size like you wish. It's a radio station or radio module. We can use handy radio, we can use the same radio module, we can use dipole antenna, we can use collinear antenna, we can use some Udo-Yagi antenna, something. Then our radio module connected to our host PC, and on this PC running some services like OSI model. From physical layer to another layers, we have some gap, and this gap will be closed by automatic pocket reporting system, gate software that will be used with our radio module. And in this case, we can increase our data range till tens of kilometers. But the next interesting things. Schematic of transmission data, sensors, processing by controller, then radio module transmitting data, another radio module receive, IBM PC with automatic pocket reporting system software, and then our database. It's normally, but if we will use the system with wild usage in the world, we can use not only our gates, one moment, previous slide, our gate, but maybe our neighbors also have the gates. And very, very often we can use just the sensor and gates we will use not only our and another gates of another uses. For example, my high altitude balloon fly to the east, and this balloon needs to get telemetry and send it to the ground. It can be used ground station with the same services. Okay, next, our results. We got new results in dress manufacturing. You can see it in influence of temperature, relative humidities between gaps of our materials. You can see the experiments was not very long, something like 2 hours, and the temperature on the street was it was winter also. It was maybe -10 something like that degrees below Celsius, and so our smart clothes showed the good and the not very good sides of our sheets. The next, for data transfer system in Cree radius, we modeled radio coverage. For example, it's radio mobile online screen. You can see the location of very famous village in the central part of Ukraine, the frequency of ISM band, the power output 100 milliwatts, receiver sensitivity. I'll say some later about the sensitivity, and the moving object with altitude 2 meters, so low antennas without masts, ground to ground walk. In this case, you can see that coverage of Shevchenko-Mazeland, I believe, Morince, very good and closely covered by our radio gate. The next, on the previous slide, was sensitivity of receiver minus 107 dBm, minus 107 dBm. You can see the usually freeze formula. Loss of pass in the free space with power of transmitter, gain of antenna. It's our pass, gain of antenna in receive pass on our base station, and the sensitivity. If you will send our data, for example, 433 megacycles and 1 kilometer distance, you will get not very big digit, 105 decibel. The next, Fresnel zone. I understand that wonderful forest, wonderful trees, not very high building will locate in our Fresnel zone is the first part of surface near our antenna or on our patch of wave propagation. So 20 decibel of for our some influences we have in this model. The next HC12 model, as I said, Scilabs 4463 plus STM microcontroller, various power output gain, frequency range very low for this model, but pay your attention. Sensitivity for different bit rates. We use different, not the lowest bit rate, but sometimes we use bit rate 9600 bits in second for usage with accelerometer sensor. And it means that our sensitivity is something like minus 112 dBm, and output power. We have two choices. The first choice, without license, it's anybody on our planet can use. No license band, industrial science medical band, for example, low power devices or frequency radio system, GMRS, and another. Your output power limit will be 10 milliwatts, and the frequency range you can see 2 megacycles. The next, amateur radio license, you have output power much more, 5 watts, or during contests in Ukraine you have possibility to transmit with power 100 watts. Sometimes we use thousands watts, but it's a different story, and the frequency range for our experiments it's much wider. So my proposition to use the superposition of existing technologies, your sensors and the licensing in free and open usage. The next picture, research results in the table. You can see standard technologies and proposed technology. Standard technology is well known for you. For example, it's Wi-Fi, cellular, and baseband for the same frequency range. And the main parameter is radius, average radius in kilometers. Wi-Fi 100 meters, no equation. Cell GSM second generation base station, extended data rate 71 kilometers. Sometimes on seasides it can be really tens of kilometers. ISM band, baseband, XB, ZigBee, half of kilometers. Maybe sometime on Nordic and RF24 L01 with a power amplifier you will got 1 kilometers on the free space, and in data rate I believe 256 kilocycles a second, but not very often. Our proposed method, the first, just use lower frequency. Just use industrial science medical band, use 433 megacycle, and you will get 1 kilometer and more data transfer range. The second, you can use amateur radio license. It will increase your output power till 5 watts or maybe more, maybe kilowatts in another country. For example, in Italy it will be 2000 watts, and the data transfer radius will be tens of kilometers, sometimes hundreds of kilometers on VHF bands. And the next, our proposition, amateur radio license, then usage automatic pocket radio system, and usage not only our sensors plus base station, and usage another base station that will increase the data transfer radius for our system, maybe till all the load. So more than 100 kilometers will be reached very simple. So we got new sensor network structure. We got wonderful accuracy from our sensors. You can see that Dallas have a good resolution and we can see tendencies. We proposed new wireless sensor network with wonderful radius and separated choice, only our sensors and our gaze, and wide used radius, for example, all over the Europe, in usage of superposition of our technology, our sensors with existing technology, existing bands, and existing licenses. The next, you can see that superposition of amateur radio and industrial science medical bands with existing services increase the radius of data transfer till the wonderful reason. Future work, some words about LoRa network. Last 10 years we use this network and on also frequency band 145 megacycles, 433 megacycles, 866 and other, but some problems. In Ukraine, you see, we have license problems. The bandwidth of our data transfer channels limited in ISM and amateur radio. So, like owner of SEP license, I have no possibility to use these models. I have no possibility to use these models like transmitter. I can use like receiver, and very often I get telemetry from low Earth altitude satellites from these models. I am use not Scilabs and Simtech models 6, 12, 76 for this reason. So LoRa is our future, but when the Ukrainian laws for SEP licensing for local amateur data transfer will agree the wider frequency band for data transfer, we will use the LoRa. So chip modulation and frequency spreading, it's really also increase the data transfer range. For example, this modulation radio model SI4463 and SX1276, the differences in paths loss will be something like 20 decibels on the same data rates. It's all. So if you have some question, I'll try to answer on them. Thanks a lot for your attention.
Thank you. I have no questions. Thank you for your report. And next presentation is the number ID 2198. 898. Okay.
Thanks a lot. Good luck.
Good luck. Thank you.
Thank you.
2198 machine learning for unmanned air vehicle rounding on round terrain. Maybe Evgen Sidorenko, it's your email. Okay, no. The next paper ID
Dear colleagues, please,
yes.
it's Любов Oleshenko, it's 2192.
Okay, yes.
Thank you. Dear colleagues, hello everyone. My name is Любов Oleshenko. I thank you for invitation for this conference and thank you for support Ukrainian scientists. Dear colleagues, please tell me, can you see my presentation?
Yes, we see.
Okay. My topic is machine learning algorithm comparison for software testing error classification automation. And today, you know, we have developed software testing is the most important stage in software development. And software error clustering refers to phenomena where software defects are not randomly distributed across software components. And it tend to occur in clusters within specific models or parts of the system. And the object of this research is creating software method to automatically classify software testing error more accurately and quickly using machine learning algorithms. And the goal of this research is to improve the efficiency and accuracy of identifying errors in software testing. In this slide, you can see some of recent research and related work, but these articles provide valuable insights into challenging and opportunities of software error clustering in software testing, and they highlight importance of using multiple techniques for software error clustering and suggest that advances in machine learning and data analysis help improve accuracy and effectiveness of software testing. But you can see we have some topics in general, and we don't have some systematic how compare this all algorithm. And for research data, we use dataset 100,000 stack traces from software companies in Ukraine for develop software method, and also use Java programming language and MongoDB as database. So in this research, we compared native-based support vector machines and nearest neighbors machine learning methods. And this research aims to develop automated software error analytic process that reduce the time it takes to identify and fix errors during software development. For this software method, you can see stack trace, which we use for error classification, contains messages about software errors and describes reasons for failed tests and shows where errors are located in software files in different levels of the libraries. And our method repeats this process for each test and removing repeated text and irrelevant information and analyze unique information specific to each test. In this slide, you can see a graphical representation of TF-IDF metric, which also we use for this research. This term frequency is ratio of number of occurrence selected word because we use errors. It's like a file with text, and we use ratio of number of occurrence of the selected word to total number of words in our document. And you can see formula in central part of this slide. Importance of word within selected document is evaluated. And in this formula for term frequency, n is number of occurrence of word in document, and denominator is the total number of words in our document. And also next metric is IDF, inverse document frequency, is inversion of frequency which with a word occurs in our file. And also you can see D is number of collection documents, and also we use number of documents in which the word occurs TI. And the choice of basis of logarithm in this formula is irrelevant, since changing basis will change weight of each word by constant factor. The weight ratio will remain unchanged. Also, in this slide, you can see we use this frequency response to help determine how important is word for particular document, and how important is categorizing particular type of document. Also, we have all of these words that belong to different categories of error. You can see in the slide, it can be product bug, error, system issue, automation issue, and categorization will be done as person that refers specific reason for failure of the test. And this information will represent in vector form. So analyzing text with machine learning algorithm means converting all of this large text into mathematical vector, and this vector will be located in multi-dimensional space where each space will refer to specific word. So you can see also for software implementation, we use client-side model. So you can see for this software, we use gateway and software implementation of proposed method. You can see we can view real-time text execution, automatic clustering test result, and specify categories and subcategories to fail test. Also, you can see in right part, we can merge multiply launches into one, attach images, pieces of code to specific test result. Also, we can use filter text result for a subcategory and adjust parameter for auto analysis. And you can see this architecture is implemented in microservices, and our system we divided into client server part, and client part includes services. For example, it's logger, agent, client, and client are API integration, HTTP clients that process HTTP request sending. And agent is framework integration. So we use special reporters or listeners who monitor test events and cause events transmitted through client. And logger is integration of logs that helps collect logs. In this slide, gateway is main point of entire application services. And this service is responsible for routing requests for proper maintenance and load balancing. And the gateway contains service registry to get a list of actual services that allowed route our traffic. And registry is tool that stores actual list of running services with added meta information. and it checks the status of each running service to ensure availability. So API is responsible for handling agent, inbound request, and the user interface. In this slide, you can see the result of this research. So you can see this software implementation allows use clusterization of data using different categories like errors in total, past, failed, product bug, automation bug, system issue, and others. And you can see this system also allows use different visualization tool to better understanding errors in our system. For this research, we compare different algorithms. It's can-near neighbors, support vector machines, and naive Bayes. And you can see number of failed tests. And also you can see results for accuracy using different algorithms. And you can see if number of failed tests. So you can see if we have number of increasing, we have different result for using different algorithms. And for our data set, you can see we get best result using can-near neighbors algorithm. So as conclusion, automatic classification of software error is important tool for ensuring quality of software. And by automating this process, testers can save time and effort. It can be 10 times quicker process. And the proposed software method has number of competitive advantages, including central location for test results, integration with other systems, ability to analyze test results automatically. And also, it allows creation custom error categories and subcategories, better organized results. And users can view self-test performance in real time, filter results, and access information statistics in form tables and graphs. And future works, you can see evaluation was limited to only 3 methods, and broader range of programs should be examined before drawing conclusions. And multiply programs that operate different operation systems often interact, and it means that information from multiply source may be necessary to identify the root cause of errors. So also hardware failures can cause errors that are difficult to differentiate from software errors. And this also is area that requires more analysis in the future. Dear colleagues, thank you for your attention. Maybe you have some questions.
Can I ask a question?
Yes.
Can you show me the 9th slide? No, before. 9th. Yeah. What do you mean when you tell us about failed tests? Can you explain what does it mean, failed tests?
Failed test, it's mean how if we have some files and we have some errors in these files, like for and we call it failed tests. So it's mean files with stack traces with errors.
Okay, and these values are accuracy, yeah?
Yes, it's values for accuracy, yes.
Okay. And for your opinion, the best is KNN, yeah?
Yes, it was for our experimental research, for our data. It's for 100,000 stack traces. It's from Ukrainian companies. We collected this data. For this data, we get this result.
Okay. Thank you so much for your answer. Thank you.
Thank you, Evgeny. You will be next, okay?
Yes, I know. Thank you.
Thank you for your questions.
Okay, now I will demonstrate my presentation. Do you see my presentation?
Yes.
Okay. Good afternoon, dear participants of this great conference. I would like to show you presentation on topic machine learning for unmanned aerial vehicle routing on road terrain by PhD Associate Professor Evgen Sidenko, Master of Computer Science Artem Trukhov, PhD Associate Professor Galina Kondratenko, Doctor of Science Professor Yuri Zhukov, and Doctor of Science Professor Yuri Kondratenko from Petromogila Black Sea National University, Mykolaiv, and CJAP Mykolaiv company. Some words about relevance of this problem. Machine learning, including neural networks, helps unmanned aerial vehicles, UAV, to move more accurately and positionally on road terrain, detect and classify objects with a camera and bypass them, adapt to changes in weather conditions based on training models and traffic scenarios, and deliver different goods like medicine, essential goods in locations with increased risk to human life. Currently, there are many areas where UAV have proven themselves. You know that maybe geodesy, cartography, agriculture, goods delivery, monitoring of long objects, transportation, and so on and so on. The main problem in this task is the choice of the effective use of machine learning for UAV routing in road terrain. In addition, the problem also lies in the need to create a training environment, which we also developed for training and testing the operation of the UAV, and then modeling obstacle avoidance situations in conditions close to reality. For this task, we use reinforcement learning and game engine Unity 3D. And the main purpose of this paper is to describe the process of machine learning and developing a system to ensure efficient routing of UAV on road terrain, which will allow more accurate movement of a certain road and increase flight stability. Let's talk about some methods which we used for UAV routing. First of all, we use reinforcement learning. Reinforcement learning is almost the same as learning with a teacher, but the role of a teacher is a real or virtual environment. The main libraries for creating AI models supported by the Unity game engine are Accord.NET, CNTK, TensorFlow, Unity ML Agents, and so on. Also, we use SARSA approach in the special algorithm of machine learning with reinforcement. The name of this algorithm reflects the fact that the main function for maximizing the value of Q depends on the current state of the agent S. The action that the agent chooses A. The reward are that the agent receives for choosing an action, and the state S2 to which the agent goes after this action. And finally, the next action A2, which the agent choosing in his new state. And also on this slide, you can see this formula, which I described before. And also Q-learning technique or technology we used for additional calculations for our model. And some results, experiments and results on this slide. You can see developed class diagram, and also developed training environment using Unity 3D. An important task was to force the agent not only to move sideways and forward or backwards, but also to rotate the body when necessary, for which the first segment of the environment is responsible. And you can see it on this slide. Also, with the help of vectors, the agent will observe the environment, and a total of 17 vectors were used. Some words about neural network. The proposed neural network structure marks 90 neurons in the input layer, 128 neurons in 2 fully connected layers, and 4 neurons in the output layer. And these 4 neurons needs us to move up and down, left, right, also rotate left, rotate right, and forward and back. So each neuron takes value -1 and +1. So to move to a more realistic environment, a prototype city with a central park in the middle was created, and in the order to specify the endpoint, an empty object was created and located in the end of the road, thus transmitting the exact coordinates of the destination. Some conclusions: during this work, a drone routing system was designed using machine learning methods, which provides high efficiency and stable flight in raw terrain. The results is a comprehensive system that allows you to perform neural network training with custom parameters for your own purposes, or use an already trained and developed model of AI, which is provided by default the drone model. And also, I would like to show you a short video. Do you see this video?
Yes.
Okay. Wait a second, please. I just okay. And on this video, you can see how our developed model of UAV moving on raw terrain and avoid obstacle. And you can see on the top of this video developed environment, and on the down of this video you can see how neural network and machine learning and also reinforcement learning works with this developed model. Thank you very much for your attention, and questions, please.
Thank you for your work. And
Thank you.
Okay, next presentation is paper ID 2198, machine learning for unmanned aerial vehicle routing on ground.
This sorry, but
it's your okay.
It's my presentation.
Yeah, thank you. As net 2213, improvement of dispenser of the liquid fertilizer dosing control system for root feeding of crops. It's your and no. Okay, the next presentation is 2221, a system of stress determination based on biomedical indicators. Now 2224 is ready, and the next 2269.
Hello.
Okay, maybe I will show a program. And who is next? Please.
I am Vitaly Savchin, and I want to present our research about system of stress determination based on biomedical indicators.
Okay.
Okay. 1 second.
I'm stop sharing, and you can try share.
Okay. Okay, my name is Vitaly Savchin.
We can see your presentation. Okay, yes.
I want to show our research about the system of stress determination based on biomedical indicators. Okay, and I show our present. And I'm from Artificial Intelligence Department in Lviv Polytechnic. And I want to present our research about the system of stress determination based on biomedical indicators. And first of all, I want to talk about the problems that our research helped to solve. Interesting in this topic is growing every year because timely diagnosis of stress and taking prediction can help people avoid nervous disorders, overwork, or negative health consequences. The most common methods which was used before and it's still actively used today is to conduct a survey and schedule types, for example. Based on the answer to the question proposed in the questionnaire, conclude the emotional and stressful state of the person. Another accurate but more complex method than the previous one is the detecting of stress using various sensors in the laboratory. For example, another one particularly interesting way to diagnose stress is the diagnosis with a smartwatch and fitness bracelet. Almost all of these devices have built-in heart rate sensors, but not all have a function for detected stress and a function for detecting heart rate variability. The latest in the list and the most innovative way to diagnose stress are intelligent systems for recognizing things of stress using human biometrics. To classify a person's stress level, the dynamics of the pulse can be analyzed using classification method. In our work, we use this way for solve a problem. The purpose of this study and research is to develop a methods for diagnosing human stress using computer technology and machine learning. The subject of this research is smart service system for diagnosis, determination, and prediction of stress. Okay, let's move. And now I want to talk about the scientific sources that we used in our research. During this study, review of 30 scientific work was conducted. There are mostly literature sources that describe the use of machine learning methods for stress detection. Some articles have examined the level of stress for a certain category of people of under concerned cancer. For example, the articles analyzes situation for the elderly or the military in a pandemic or in pandemic. The random forest algorithm, logistic regressions, and other classification methods are usually used to diagnose stress in the analyzed situation. In contrast to the extinction approaches, Our research proposed a system that determines the level of stress for anyone by entering concurrent biometrics indicators. The proposed smart service system will not require special devices for their measurements. Diagnosis will be performed with HRV or heart rate data obtained in any convenient way. The obtained results have two special practical value for diagnosing stress in students during training for office worker. Recently, stress detected systems have begun to integrated into smart watch and fitness bracelets, and the new scientific article and research in this area have been published. This indicates that at the moment the research topic is still relevant. Okay, next now let's move on to the description of the algorithm that we proposed to solve the formulated problem. We need to classify stress into three categories: no stress, time per, and two categories with stress: time pressure and interruption. To do this, we will use a serial type neural network that will have an input layer that will input data and one hidden layer and the last output layer, which will already return the data and divide it into three categories. So we need to develop a sequential model with three layers, use the activity function for three layers, and configure the model training. On the development model, on the first two layers, we use the ReLU function for activation, and on the last layer, we use the softmax activation function. Okay, and the ReLU function you can see on your screen. It is max value without 0 or x, where x is the input value of the neuron. This type of function is used in the work on the input and hidden layer of the model because it perfectly copes with the task and is quickly calculated, so it optimizes the neural network. But for the third layer, it cannot be used because the effect of multi-layer will be lost. For the last year, we used softmax. Softmax function you also can see on your screen, where x the value of the input data, the number of classes in the classifier, j it's list from 1 to k. For our neural network, we choose have three layers. On the first layer, 34 neurons, because it's the input layer, and the studies dataset has 34 input parameters. The last layer is the output layer, so input's number of nodes is also known. There will be 3 because the system will classify 3 studies of people stress categories, and only the hidden layer remains available to experiments with the number of nodes. For example, we first set the number of nodes to 30. In this case, the number of weights can be calculated as following on the screen. 1020, it is the number of weights between the first and second layer, and between second and third layer, we have 90 weights. And summary, the total number of weights is 1110. Okay. And now we can see the results of neural network training. You see table where is value for loss and accuracy. We using loss and accuracy not only for training data, but for validation data for better experience. Accuracy and loss value for epoch with approach with a steep of 10 epoch. 1, 10, 20, and 100 in end. Okay. Next result, it is the graph of the learning rate. You can see dependence of losses on the approach number, loss for every epoch. Okay, and next graph, it is accuracy, and we can see accuracy for every, also for every epoch. Value of accuracy for every epoch. Okay, and main result, it is our prediction in new data. And you can see table with prediction for random data. In order to run the model to the new test data, you must pass an array data to the input of the predict method and run. The predict function returns the probability that each record belongs to different classes. The table belongs show for each the probability of one of the classes is 1 or a number close to 1, and for other classes the probability is a number close to 0. And we can see 3 column in table, and every column mean one categories of stress, no stress, and stress with interruption, and stress with time pressure. For example, for first test data, value is no stress. For second is time pressure, and last test data means also no stress. Okay, and conclusion in the research is investigated method of determination stress in human and development of smart service system in medicine to automate this process. This paper evaluated exciting research in this area. We conducted a study of the method of determining stress level based on biomedical indicators. Also, we have developed a system that is relevant for use in many different areas. For example, such a system is convenient to use in office firms to prevent overexciting of workers, to prevent emergencies in jobs with a high level of human impact, where human life is endangered, and also for daily use in healthcare. The smart services system work with input data based on heart rate, variability indicates neural network training has been launched in 100 epoch. In each epoch, the results of accuracy and loss were recorded. As a result, the classification problem is solved. we get 99% accuracy. Is a very high score. Okay. In the screen, you can see references, part of references in our research. Okay, thank you for your attention. Maybe you can, any question?
Thank you. Yes, I have a question. And what biomedical indicators are used to determine stress level?
Biomedical indicators, it is variability, our heart rate, variability, and another numerical data about variability, heart, our heart, and
Okay, thank you. And the next paper is paper ID 2269.
Okay, thank you.
Thank you, goodbye. Fairness audit and compositional analysis in trusted AI program. Now, next 2275.
Yes, I can present it. Hello.
Okay. Please show your presentation. Okay. We see it.
Thank you for this opportunity to present this our research and titled Fairness Audit and Compositional Analysis in the Trusted AI program. So the scope of this research is the fairness audit of black box learning systems. And the question is simple. To what extent the decisions of a trained machine system can be trusted? We are talking here specifically about black box learning system, which do not provide additional rationale or explanations for its decisions. So the reasons for this, for the audit are becoming more transparent because the machine intelligence systems are taking more and more active role in different domains of society, even in some critical domains. And it's important to know to what extent the decisions can be trusted. And there are certain limitations in the existing methods of verification and analysis of decisions of machine systems. Basically, they rely on massive sets or massive sets of known data, so that the decisions of the systems can be verified. These sets are not always available, and also importantly, the question of bootstrap can be asked as to can the decisions, can the information itself in the trusted set can be trusted. So for this reason, we developed this approach, which do not rely on massive amounts of trusted decisions and provides additional perspective in the analysis of fairness and trust audit. So there are here some observations. Fairness is not accuracy. Can be easily illustrated by an example that these are not equivalent notions, but highly accurate system can still be biased in certain aspects of decisions, and the other way around. And secondly, second important point is that fairness and bias are relative. So they depend on certain objective, which needs to be formulated for the decisions, and the same decision, depending on the objectives, can be considered as fair or biased. And there are some examples here. But now we're moving to the to our proposal here, and the idea is based on the conceptual decomposition of the data sets. The conceptual analysis of data sets is a known discipline in machine learning, and there are many different approaches, many of them successful in their own domain. And here we show some examples. PCA is the simplest one, a linear decomposition of data set into characteristic clusters. It works in some simple cases. Then we can show here a decomposition, low dimensionality reduction with generative neural network models. Here we have a data set of geometrical shapes. There are three different types of shapes here, basic geometrical shapes like triangles or squares. And we can see that model can distinguish between these two shapes even without knowing the semantics of the shapes. So it can place them into different geometrical areas of the latent space, and thus distinguish between different types of shapes. Also, there are more sophisticated methods have been developed, such as manifold learning, and we could see that it works with more complex data types, such as images of digits here, and also completely different types of data we used previously in published results. So the bottom line is there are a well-developed array of methods which allow to decompose or factorize data sets by their characteristic content. The content are general types or patterns or concepts. How does that help us with fairness analysis? So here we can illustrate that it can provide additional perspective on the analysis. For example, if we can, one observation I have to make on the previous slide is that most of these methods of analysis are unsupervised. And why is it important? Because they don't, it doesn't depend on availability of massive amounts of known data. This is exactly the problem which you pointed out in the beginning of this presentation. Coming back to here, the explanation, suppose we have this data set of inputs, and black box system produced certain decisions on these systems. How do we know are these decisions fair, or they have some elements of bias? So, well, this analysis does not provide a definitive answer, but it allows to detect basis and could allow to detect a bias in some cases. For example, we can consider conceptual decomposition of a set of inputs, which is characteristics of decision of situations or cases on which decisions are made by the system, into characteristic patterns or classes. Here we have an illustration of this of such a case. Suppose we have detected three characteristic types of patterns. Now we can obtain distributions of decisions not only across the entire data set, but also in each of the characteristic subgroups or types. And now, having obtained these partial distributions of decisions as across the data set and across and in the characteristic groups, we can compare those distributions and then possibly make some decisions. So here we can provide some specific examples. We have three different types of inputs. Here, in this case, we coded them with this color. And we obtain distributions of decisions because again, the decomposition is unsupervised and allow us to produce this distribution of inputs into characteristic groups without any prior knowledge about the data. And we can produce this kind of distribution of decisions or characteristics of decisions across these concepts or general types. Now, of course, we can see if we are compatible, if we are more or less the same, or there are differences between groups, and then consider these differences, possible differences, based on the, as was mentioned previously, on a fairness objective. So in this case, for example, we see what there are two groups which show very significant variation between their decisions, yellow and green. Really, very strong variance between these two groups. Now we can consider the fairness objective, the objective for the learning system to produce a decision, and decide whether this difference is justified by some characteristics of elements of these groups, or it's spurious. It means that there is no justification from the perspective of the learning objective of the system for this difference. And if there is no justification, then in this case, we can pronounce that the system is biased. Again, this analysis did not require any additional data. So this was based entirely on the conceptual composition of the data. And another case here is illustrated. It's sometimes happens in practice in case where a system develops spurious bias by some accidental connection of a decision to some of the values of a parameter, which can be pretty hard to debug and understand. But again, in this analysis of composition can provide certain insights into such audit. So in this case, we consider distribution of decisions in a single group, in a single type. And again, we can find the general characteristics of distributions of decision in a group, and then look at the samples where decisions are significantly differ from those in the group, and which we call here an outlier segment. And if we have this outlier segment identified, we can now examine it more closely, specific samples in this outlier segment, to see what produced such a significant variation of decision. Is it some problem in training the system? Is it something architectural in the system? So again, we have some perspective to analyze and determine where this variance in the decision is coming from. So to summarize this, conceptual decomposition is a useful additional perspective in the analysis of audit, in the audit of trust and bias, because it's generic. It can be applied to different types of data. It's unsupervised. It doesn't require additional significant volumes of trusted and known data. And it can provide additional perspective in the analysis of distributions of decisions and allow it to make statements about the bias in certain cases. So for that perspective, for these reasons, we think it could be useful in the analysis of trustworthiness, in the trustworthiness program of black box learning system. Thank you for your attention.
Thank you. I have a question. How does compositional analysis contribute to the evaluation of fairness in AI systems?
Right. It allows us to make additional considerations and analysis because it produces a whole new perspective by producing partial distributions of decisions across characteristic groups. So we have additional dimension for the analysis because now we have distribution of decisions not only for the entire data sets, but also for each of the specific groups. Now, because this compositional analysis, which can be performed with different methods, allows us to identify the groups explicitly. So we can see a look at the characteristics of the groups, and we can also monitor the distributions of decisions. And based on these two variables, the distribution of decisions and the belonging of samples to different groups, make the conclusion about whether the distributions of decisions between identified general types are compatible with the fairness objectives, or perhaps there is a case where we are not. And if we are not, if we observe the cases where distributions are not compatible with the fairness objective, in that case, we can pronounce that the system is biased.
Okay, thank you very much for your presentation and your work. And the next work is number 2275. Could you share the screen?
I'm sharing the screen.
Okay.
Is it visible?
Yes, we can see you.
Okay.
But it's too small. Oh, okay. Perfect.
Okay. Good
You
evening,
can
ma'am.
start.
My name is Rupa Rani, and my co-authors are Prashant Upadhyay, Mr. Satyaprakash Yadav, Mr. Santosh, and Mr. Victor. And my topic is orderability-based botnet recognition utilizing AI model, artificial intelligence model in the Internet of Things framework. First of all, I'm going to explain abstract. Actually, advanced hooligans are taking advantage of the chance to consider associated devices with their IoT malware. As a result, several new breakthroughs like Internet of Things, etc. associated gadgets are gradually becoming more advanced, and the malware is focusing on vulnerable gadgets. Basically, in our proposed model, I am using an abnormality-based simulated intelligence model that can capably recognize the threatening practices in the association using change hyperlimit light GBM computations. And our framework can be reached to identify new sorts of impending assaults, and also we will accomplish a lightweight nature. And this model is ready with the boat IoT dataset, recently boat IoT dataset. And our proposed model shows approximately 99.9% precision with the 0.01% real regrettable on only one added cycles. I will explain it in the proposed approach. Before that, I'm going to explain introduction part. As I told you, our model is to identify new sorts of impending assaults and also accomplish a lightweight nature. And we are using a boat IoT dataset, and particularly botnet assaults are tremendously difficult subsequent to contaminating the botnets. The assailants have some control through the C and C server and send off assaults on the person in question. Our proposed discovery design can recognize the non-assault and the changes also. And the framework can be reached to identify new sorts of impending assaults. Besides applying the component determination approach, this framework accomplished a lightweight nature, which I told you already, and the best location precision. Here, I have shown the literature review, some of the literature review I've mentioned, which is very near to our proposed work. The analysts have proposed different ways to deal with, arrange, and identify malignant exercise in the IoT network. Utilizing distinctive learning calculations, artificial intelligence, and profound learning strategies are utilized to develop these arrangements, utilizing different open source accessible datasets. Means we have used a different datasets, and not we, author has used the different datasets in reference number 12. And in reference number 9, Linde developed a model, LSTM, long short-term model, for the location of distributed denial of service assaults. And in reference number 21, they proposed a model involving layers of recurrent neural network, following organization for the identification of botnet. And Coronatius played out a similar report with many AI methods and proposed an arbitrary Timberland model. They have compared with the k-nearest neighbor, logistic regression, support vector machine, and other algorithms. Now, this is our proposed methodology, where we have taken a packet captured file of network, and then we have taken a raw data sets. After taking the data set, we pre-process it. Means we will remove the redundant data from the data set. After cleaning, normalization, and transformation, we are using feature engineering or feature extraction in our model. Feature extraction means in our data sets, we are taking some parameters and we will create a new parameter also. After that, we will use a SMOT algorithm for balancing of the data set. Now, SMOT is an algorithm that performs data augmentation by creating synthetic data points based on the original data points in SMOT procedure. After applying this SMOT procedure, we are preparing a LGBM model, that is a light gradient boosting machine. It's a framework which is based on decision tree, and we will increase the efficiency in our model. Then we will train our model and then test the data and identify benign attacks. I've explained the same thing in this part. Basically, we are doing it in three terms. First, in the first place, in the fourth line, the information planning stage. In this, we will clean the data set, as I told you in the last slide, with obscure qualities. Means the quality which is being unclear. And then at the point, standardize and change the data set. Next, the significant elements are utilizing the chi-square calling techniques is utilizing to choose the main highlights by using the formula x square equal to, which I mentioned here. And not last, the component designing cycle assists the model with the further developing exactness and the computational overhead by lessening dimensionality and choosing significant highlights. Now, the result and the discussion, as you can see in the graph on the right side, we have found 99.9% precision and 0.01% with true negative. In this stage, an element choice strategy in our analysis is connected element information is extricated from approaching all bundle information, which depends on the characterized highlight set for every classification. And an element choice strategy is applied for the framework to be lightweight. Basically, our focus is to identify the lightweight. The bot create the line on occasions, getting orders from the bot is by means of the order and control server. And the result I have shown in the graph last. Now, this is the comparative analysis. Here, we have shown the various algorithms with their accuracy, precision, recall, and F1 score. And then last, you can see our model where I have used a smart procedure and feature extraction, and we got 0.999% accuracy with precision 1 and recall 1, and also F1 is score 1. This is the conclusion part and also the future work. Basically, this is an abnormality-based model proposed to orchestrate poisonous events among inertias in the association. And this model is ready with a high inconsistent data set. First and foremost, the data set is prepared by cleaning. As I told you in our proposed approach, first we clean the data or remove the redundant data and etc. Normalize the data and the missing characteristics, then normalizing and changing the data. Secondly, misleading produce minority tests to change the data set using destroyed oversampling strategy. With the fast advancement, the IoT innovations, the digital assaults are for most part focusing on these gadgets. Particularly botnet assaults are difficult in these conditions, and the assailants have some control over these gadgets through the C&C server. C&C server, it's a command and control server, basically a computer that is controlled by an attacker and send up assaults on the person in questions. Our proposed discovery design can recognize the non-assaults and their changes, and furthermore, the framework can be used to identify new sorts of impending assaults, which is not identified in the previous research. Besides applying the component determination approach, the framework accomplished a lightweight nature as compared to the previous one and the best location precision. In future work, we can explore the ordinary traffic design on the various qualities of the IoT gadgets to broaden the orderly sum motor for distinguishing obscure goes after actually. And we will execute a test bed to approve the exhibition of our proposed framework and propose how to seclude the compromised gadgets. That's it. These are the references which I have used. Thank you.
Okay, thank you. Any questions? Okay, I have a question. How does AI model help to identify botnets in the Internet of Things framework?
Actually, botnet, as we are doing feature extraction, and it can produce new feature which will simplify and speed up the data transformation, and that will enhance the efficiency as compared to the previous one.
Okay, thank you. Thank you very much for presentation. And the next work is number ID 2226.
Yes, I'm here.
Okay.
Dear colleagues, can you see my presentation?
Yes, yes, we can.
Okay,
You
dear
can start.
colleagues. Yes, thank you. So my name is Lyubov Oleshenko. Let me introduce our research, paradoxical properties of the perceived curve in the intercepting and fugitive problem. The author of this idea is professor of our department, software development, of National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute. So I will introduce our mathematical formulas, which we describe for, and this mathematical decision can be used in different subject area. You can see in some cases, with passage of time, the old problems of finding perceived curves, one perceived, one fugitive, on plane, for example, you can see in this picture, are received in new formalization. And this may be related to the possibility of changing different strategies for avoiding interception by fugitive due choice one another quality criteria. For example, as criteria of quality for this task, maximum advance of fugitive towards certain border, which is considered a lifeline for fugitive, can be considered. And from practical point of view, solving the problem of person, one fugitive in production with new quality criteria will be relevant in such areas, for example, transport, logistics, military tasks, sport events, computer games. So, as you can see, object of this research is process of chasing fugitive who tries move as far as possible in direction of certain given limit before moment of interception, moving along as inclined straight line. And the subject of this research is properties and characteristics of first curve, which influence the choice as fugitive successful escape strategy. And in this slide, you can see recent research which is relevant to our subject. But you can see in this article, a review of this literature source showed that problem of pursuit with formulation in which maximization of fugitive movement towards certain saving limit due selection angular coefficient of escape line was chosen as quality criteria and was not considered before. Sorry. So you can see a picture, and you can see our fugitive line. And what is mean? Our task is to find trajectory L of pursuit. In our research, we use word on the water. Next, second, point of the plane at which it can be will catch up with board fugitive. And third, angular coefficient that ensures maximum displacement of board fugitive along horizontal axis in direction of border between two countries. And the flow rate of receiver is not taken into account. So we start in position of two moving points, one of which is chasing the other. And on the shore, you can see is axis OX of receiver, two boats stand at distance y0 equal 1 from each other, coast board for boat U and border for boat V. So you can see reservoir separates two countries as natural border between them. At the same time, runway boat V is trying to cross the body of water as quickly as possible in direction of the border, which we call lifeline AB, between the two countries. And we believe that this border is parallel to shoreline of start two boats. And for chasing boat U tries to overtake the boat fugitive V before it reaches certain point, which in border AB of two countries. So we use initial time T0 is equal 0 for the later boat V begins move along straight line mu. And then boat U starts at the same time, and this process pursuit chooses direction of movement, so current for boat V on the plane. And this time pursuit boat U has constant speed U and alpha times greater than speed of boat V. And fugitive task is to move as far as possible in direction of border AB between two countries, choosing for escape optimal angular coefficient key of inclined line with constant alpha coefficient. So we use L, its trajectory boat U for pursuit curve, and we identify location of boats of plane with points U and V. So X, Y is coordinates for point U, and also we use coordinates of point V at current time T. Then we draw tangent at point X, Y for U to our line. Connecting points U and V establish relation for derivate function y of x. And you can see this formula 1 Then we express variable for coefficient from this equation and find time derivation to this variable. Then we determine ratio alpha for speed models for these boats, taking into account we have equation 4 for our u, and we taking account previous formulas 3 and 4, and we obtain equation for trajectory L. You can see is equation 5. Then we rewrite differential equation of desired curve differently. So you can see we then add two boundary conditions for this equation, y of 0 equal 1 and derivation of 0 equal minus infinity. And to find first curve, we have boundary value problem with differential equation 6 and boundary condition 7. So in equation 6, we replace our variable and obtain nonlinear differential equation for second order. Then this equation allows two order to be reduced one of following substitution in made. You can see it's formula 9. Then in u variable equation 9, we take following form. So we solve differential equation and we get equation 10. Then we reduce by factor p of z not equal 0 and get equation with separated variables. You can see it's formula 11. Then we, after integrating equation 11, we get equation of first order. You can see it's equation 12. To determine first constant in equation 12, we use relation z equal y minus kx. And boundary condition 7, and as a result, you can see for limit transition, we obtain the first constant, it's formula 13. Then we express function p equal derivative of z from equation 12 and 13 in terms of z, and we get equation 14. Then we denote right-hand side of relation 14 by function f of z k alpha. And as a result, we got equation for first order. You can see it's equation 15. And then we write second integral using this formula, and then we get 16 equation and supplement this expression with expression for y of z k alpha, which together describe first trajectory y of x in parametric form for pair of function, and variable z, x as parameter. And you can see equation for 17. So you can see for this picture, a blue curve represents trajectory for plane boat V, and red curve represents trajectory of boat U. And the point of the plane in which the escape boat is apprehended has coordinates. You can see we found this point. Geometrically, fact of arrest means that red curve is tangent to the blue line. And we also required time t to detain fugitive boat V in process of pursuit, and you can see result of this using these formulas. And we calculate distance as traveled by pursuit boat U during pursuit using this value. Next, you can see next picture presents curve that reflects dependence of change of distance x0 k alpha of arrest on runway, both depending on angular coefficient k of direct movement fixed coefficient alpha. And it has a well-defined local maximum, you can see, which identifies that there is certain non-zero angle of this direct movement escape boat, and this gives us opportunity to achieve the maximum movement towards border between two countries. So you can see we find coefficient alpha equal to and key equal minus 0.4, and you can see this point and this result for this local maximum. Next, you can see considering indicates in previous figure paradoxical property of pursuit process. Using formula 17, we establish dependence. You can see in this picture, and we found x for maximum is a maximum value of fugitive v movement along OX axis with variable coefficient k and fixed coefficient alpha equal to. And graph of in this picture shows point of maximum movement of fugitive v along axis OX with non-zero angular coefficient k equal minus 0.4, which acts as parameter for this curve. So then we find out behavior of quantity of this point under conditions that coefficient alpha goes either to infinity or to unity. And you can see picture graph of dependence of value x on coefficient alpha for fixed value for angular coefficient k. And also you can see from behavior of this curve, we can see if coefficient alpha go to infinity, then distance x0 k alpha, at which latter will define tends to 0. And on the other hand, if alpha go to 1, it means speed of boats equal, and then identicate distance goes to infinity, that arrest of runway boats will not take place. In this picture, you can see corresponding graph of dependence of the value k on coefficient alpha, which is constructed for angular coefficient of escape line that provide maxima, of course, on this graph. And research result, you can see table. So we found different values using in this case parameter alpha equal to is fixed and speed of fugitive is equal to 1. Parameter k, you can see, varies from 0 to 1. And from given table, it follows that best escape strategy of fugitive is to choose straight line with tangent of slow angle of straight line of escape equal about it's optimal for k equal 0.4. And the same time, Pusher will spend t equal 0 if we calculate 0.790 units of time and travel value for s. You can see 1.581 units of path to delay him. So for conclusion, you can see urgent problem building mathematical model of process flat pursuit with selection of optimal angle for inclination of line escape with aim of avoiding capture of fugitive by Logan's moment has been solved. And fugitive goals is to advance as far possible of lifeline of border between two countries, choosing due optimal angular ratio of straight line to escape. And this equation, the equation of pursuit optimized curve is obtained in parametric form. And this numerical analysis was carried out. Influence of parameters of pursuit process on the form curve was investigated. Also, we find best parameters and best case in result comparison to find optimal path. And first time, the dependence of change in the distance to the point of capture of fugitive depending on magnitude of angular coefficient in this moment along influence line, a fixed angular coefficient was established. And we get paradoxical characteristics, it's shown that this dependence has well-defined local maximum, which identifies presence certain non-zero angle of inclination and fugitive movement line, which provides him with opportunity to reach maximum movement towards lifeline of border between countries. So new paradoxical phenomenon was found for successful escape, strategy of choosing angle of inclination of straight line equal to 0. It's moving along shorter segment connection to parallel straight line is not correct. So for future development, mathematical result of this research may also be useful for military task, computer game industry that needs movement engines for much realistic in-game physics. Dear colleagues, thank you for your attention. Maybe you have some questions.
Thank you. Okay, and I'm interested in how your investigation can improve military task. Which task for military?
It's can be for solving problem if we have some planes, some escape problem for maybe drones. So we can use some, because it's like find some line to how to best to escape for some situations. So it can be for object in the sky, for example. It can be objects in water, and also so for military it can be different situation in which we can use this approach.
Okay, thank you. Thank you very much.
Thank you for your questions.
The next paper is number 2294. Sector independent integrated system architecture for profiling hazardous industrial wastes. No. And the next 2277. Determination of branch. No. Okay, and next 2218. 18. Now maybe I will show you a program. And the next speaker will find. Okay, we will finish our section in a half. Okay, this 2277, 2218, and next 2306. No, maybe this.
Yes, I am present today.
Oh, it's amazing. Okay.
Well, thank
I
you.
stop sharing screen and you have a time.
Well, the topic of my paper is perspective.
Can you share the screen?
Unfortunately, no, because according to this day, it is holiday religious, and I am not in the home with my notebooks, and also time was shifted, and I'm sorry. The topic of my report is investigation of drawbacks of software development artifacts reuse approach based on semantic analysis. The first, let me introduce myself. I am Olena Chibanyuk. I am working in National Aviation University in Ukraine. I am a doctor of technical science and professor of software engineering department.
And let me start my work. Not work, but explanation. A successful software development process today needs following to many business requirements. For example, low code, speed development, reducing of development costs, high quality of codes, and others. Answers to it, organization of development process involving techniques that satisfy to the next requirements. The first, software assets reuse, high level of software development processes maturity, automation of routine activities in a software development process. One of the ways to answer to these business requirements is involving activities of asset-based development into modern software development methodologies, such as test-driven development, behavioral-driven development, and software product line approaches. My task is to propose the approach for estimating effectiveness of software use based on comparison of semantic attributes of software assets and requirement specifications. Keywords in natural languages and OCL expressions are chosen as semantic attributes. In forward engineering activities, semantic attributes are prepared in requirement analysis. In reverse engineering activities, semantic attributes are prepared when software asset repository is composed. I have the next research questions. The first, it is propose a structure for software assets repository. Aim of repository is to systemize information about assets for future use. Assets are gathered in repository related to concrete problem domain. As the next question, propose a structure of requirement specification which summarize requirements descriptions and semantic attributes of requirements. And other questions, development of a comparison algorithm for matching semantic attributes of repository assets and software requirement specification. And the next, propose a model for approximate comparison of semantic attributes allowing comparison semantic of requirement specification and assets from repository. Of course, it is necessary to define criterion for full and approximate matching of OCL expressions. The last one is perform an experiment, verifying proposed approach and comparison model. I will describe what happens because when I propose structure of software repository, key idea is to take keywords in natural language and OCL expressions that define some conditions of using or reusing some concrete software artifact. And when I propose a requirement specification, also I describe as using OCL expressions in order to take a formal model of some texts in natural language that we have from customer. And also we have domain tree, and according to this domain tree, some words are selected. It is keywords, and we are going to compare one formal model as OCL expressions and keywords in natural language in other formal model to OCL expressions that are related in domain repository. And it is not classical using of OCL expressions because in Western Europe, OCL is used in order to generate meta models. Meta models are grammars, and usually in software engineering, we understand the grammars as class diagrams plus OCL expressions that allows to enrich these diagrams by means of some semantic. And I practically didn't meet the works of scientific words that use OCL in the requirement analysis stage and in domain engineering from this point of view. and it is my novelty. And I have maybe several minutes to take some drawbacks that I frankly investigated. First of all, OCL, it is a language, and if you have some ideas as C++ or Pascal or maybe C#, you may take the same expressions by means of different operators. In OCL, we have the same, and this problem is proposed to be solved, like to set up different priorities for different type of OCL expressions. And I've also introduced a formal representation of OCL expressions. I represent them as a graphs. It is totally new ideas. And if we have graph representation, we have a flexible approach that allows us to compare some expressions as part of chunks of the graphs. And it is define drawbacks. And maybe in order not to waste the time, I will take from conclusions according to these research questions, according to my novelty, and according to proposed ideas how to solve the problems that were defined earlier. I may say that my paper and my work is concentrate on questions of transforming semantic between different tools and perform the solid tasks. The different scenarios that we have present indicate the need for semantic consistency between specification and analysis tools for the reliability and the preservation of semantic of models. To achieve this goal, the following points are important for improving the interpretability of tools during designing and analysis of software system. Aim 1, clarify the semantic difference induced by formalisms and engineering domains as soon as possible to ensure the reliability and consistency of models during all design stage. Thus, there is a need for methodologies to indicate possibilities, adaptations between different representations. And the last aim is to use identified semantic difference to capture adaptation models, preserving the semantic of the exchanges models between design tools. And some models should be expressed in more higher level in order to be understood like meta models. And also it is necessary to develop a flexible tool that allows to consider graph representation of OCL expressions and allows to consider more types of OCL expressions that I designed. Frankly saying, I have designed only 4 types, and only 4 types of OCL expressions. It is not enough for flexible considering of some semantic attributes of software development artifacts. I suppose I was compact, quick, and if you have maybe some questions, I'm ready to answer.
Okay, thank you. Any questions?
I look through chat.
No questions.
Well,
thank you for your presentation.
Excuse me for such conditions that happened.
Okay, it's okay. And I think all joint colleagues is presented. Yes, works. And
yes.
I think we can finish our section, and I want to say thank you again for your participation, and I think our section is very productive, and thank you for your scientific research and for your time in all day in some cases, and thank you very much.
Thank you.
And goodbye.
Thank you very much.
Goodbye,
Thank
nice
you. Holiday.
Goodbye.
Happy holiday, happy Easter for Ukraine. Okay,
Yes,
bye-bye.
Yes, and you too.